Hi, I'm Jason Roberts and welcome to this DaVinci Resolve Fairlight Fundamentals course. You'll learn about the essential effects, how to mix audio, how to automate properties over time, and much more. Most of what we'll cover in this course applies to both the free and paid versions of Resolve, though some effects we'll look at, like the voice isolator, are only available in the paid studio version. Whenever I mention keyboard shortcuts, I'll be using the PC ones, but Mac users just need to use the equivalent keys such as Option, Control or Command. Remember, you can also go to the DaVinci Resolve menu at the top left and then choose Keyboard Customization to find any keyboard shortcuts. No part of this course or associated materials may be transmitted or reproduced in any form or by any means without prior written permission from the author. The information contained in this course and any associated materials is provided on an as-is basis without warranty. The author assumes no responsibility for omissions or errors or for losses or damages resulting from the use of the information contained herein. Errors and omissions accepted. All trademarks reproduced, referenced, or otherwise used herein which are not the property of or licensed to the author are acknowledged. Trademark names that may appear are used purely in an editorial fashion with no intention of infringement of the trademark. This course is organised into 8 main teaching modules, plus this introductory module and a summary module at the end. In Module 1, we're going to get a quick refresher on the physics of sound, such as amplitude and frequency, because these are fundamental things that we need to know as we work through the course. In Module 2, we'll get to know the Fairlight user interface in a bit more detail, because if you've never used Fairlight before, it can be really overwhelming when you switch over to the Fairlight page in DaVinci Resolve. In Module 3, we'll start to look at how we cut, move and make clip level adjustments. This is just some of the bread and butter work of working with audio in the Fairlight page. We'll then move on to Module 4, where we'll look at some essential track level adjustments, tools and effects that we can make. And when we make changes to the track level, we'll learn that they affect all clips on that track. In Module 5, we'll learn about a super powerful feature of Fairlight, and that's the ability to automate both clip and track level parameters over time to really finesse the mix and get things sounding great. In Module 6, we'll learn about buses, routing, groups, VCAs and sidechains, which are lots of different ways we can really tailor how Fairlight works with our audio to get the results we want. Also, using things like track groups can really save us time when we're editing audio. In Module 7, we'll see how we can mix lots of different sounds together to create an overall balanced result where we can hear everything we want to hear clearly. So we'll learn how we can mix together sound effects, music and dialogue so everything sounds like it belongs in the mix. In the final module, we'll learn how to check and also manipulate the overall loudness of your video to make sure it meets the client's or delivery platform requirements. And just a quick tip to get started, always check with your client or customer or wherever you're delivering your project to before starting work, because this is going to save you loads of time and hopefully mean you don't have to redo any work. Before we dive into the specifics of editing and mixing audio in Fairlight, it's important to understand the basics of sound itself. After all, everything you do with sound in Fairlight is based on how sound works in the real world. So in this module, we're going to start off by determining what actually is sound. Then we'll look at some properties of sound, including amplitude, frequency, decibels, and how sound behaves in different scenarios. We'll also learn about the importance of room acoustics, and we'll briefly touch on the concept of studio monitoring speakers. So what is sound? Sound is a mechanical wave. It's vibrations that travel through the air, water, or even solid objects. When something vibrates, it creates fluctuations in air pressure. These fluctuations, or sound waves, travel through the air or the medium until they reach our ears. For instance, think about a drumstick hitting a drum. When the drumstick hits the drum, it causes the drum head to vibrate. Those vibrations push and pull the air particles around the drum head, creating sound waves. When those waves reach your ears, you perceive them as sound. So now that we know what sound is, let's talk about how we perceive the intensity of sound. This is where we can talk about amplitude. Amplitude refers to the height or strength of a sound wave. It determines how loud or quiet a sound is. The bigger the amplitude, the louder the sound. In audio editing, when it comes to the amplitude of sound, we can also think in terms of dynamic range. This is the difference between the quietest and loudest sounds in an individual clip or the timeline as a whole. When you're editing audio, you're often adjusting the amplitude to either increase or reduce the volume. This is why understanding how amplitude works is so important when mixing. It's one of the major ways we control the balance between different elements of a soundtrack. Think about the volume buttons on your phone. When you press the up button, you're increasing the amplitude of the sound. When you press the down button, you're reducing the amplitude. In DaVinci Resolve, amplitude is visualized in the waveform display of the clips, where taller waveforms represent louder sounds and shorter ones represent quiet sounds. Next, let's move on to frequency, which plays a key role in how we perceive the pitch of a sound. And by pitch, we mean something like the low-pitched rumble of thunder or the high-pitched sound of a smoke alarm. Frequency refers to the number of vibrations or cycles that occur every second in a sound wave. The unit for frequency is Hertz, or Hz for short. A low frequency or low Hertz number means there are fewer vibrations every second, while a high frequency, a larger Hertz value, means there are more vibrations every second. 1000 Hertz is equal to 1 kilohertz. When we talk about pitch, we're really talking about frequency. A high pitch corresponds to a high frequency, while a low pitch corresponds to a low frequency. For example, a high-pitched sound might be a whistle, while a low-pitched sound might be a deep voice or bass guitar. The range of human hearing typically starts from around 20 Hertz all the way up to 20,000 Hertz, or 20 kilohertz. So we usually focus on this human hearing range when we're working with audio in Fairlight. We also need to understand how we measure the loudness or volume or amplitude of the sounds we're editing, and this is where decibels come in. Decibels, or dB for short, is a logarithmic unit used to measure the intensity of sound. It's not a linear scale, which means that a sound at 40 decibels is not twice as loud as a sound at 20 decibels. It's actually much louder. So we can measure loudness in decibels, or dB for short. When it comes to measuring loudness in the real world, 0 decibels is the faintest or quietest sound we can hear. 30 decibels is the sound of whispering. Around 60 decibels is typical for normal conversational talking, and over 85 decibels for extended periods may cause permanent hearing loss. And if the sound is loud enough, even if it's not for extended periods, it can cause permanent hearing loss. In digital audio mixing and recording, you'll often see a 0 on a meter where the sound is really loud, and negative dB values as sound gets quieter. We'll learn more about loudness and metering in Module 8. Alright, we've covered how sound is made and how we perceive its characteristics, but how does sound actually behave in different environments? The first way sound can behave in the real world is with reflection. This is when a sound wave hits a hard surface like a wall or a hard floor, then bounces back. This is why a sound can seem louder or more distant when you're in an empty room versus a room filled with soft furniture. In audio studios, we use acoustic treatment like sound-absorbing panels and foam to control these reflections. Next up, we have absorption. Softer materials like curtains or foam panels absorb sound. This reduces echo and reverberation, or reverb for short. In a recording studio or mixing room, acoustic treatment is designed to reduce unwanted reflections from interfering with your recordings. It also helps when you're editing audio using speakers because you're not hearing all the reflections from the room. Instead, you're hearing only what's coming out of the speakers. And the third thing we can talk about is something called diffraction. This is when sound waves bend around obstacles or spread out when passing through openings. It's why you can hear people talking around corners or behind walls. When you're mixing or editing audio in Resolve, the way sound behaves in your recording space can affect the clarity and accuracy of what you're actually hearing while editing. You should know how your environment influences the sound coming out of your speakers. Adding sound absorption to your editing room will help you make better decisions during the audio mixing process. We'll talk about speakers in just a second, but first, let's just touch on room acoustics. This is essential when setting up your listening environment for audio mixing. The acoustics of your room, the size, the shape, and what materials things are made of can significantly affect the quality of the sound you hear when using speakers. This is not such an issue when using headphones because they're right up against your ears and you're not really hearing any reflections from the room. For example, a small room with hard surfaces will cause sound waves to bounce around all over the place, which can lead to unwanted reflections and muddiness when you're listening to your mixes and trying to hear what's happening. Whereas the same room with acoustic panels on the walls and ceilings and maybe thick carpet, maybe a soft couch will sound so much different. For now, just remember that understanding how your recording and editing space affects sound will help you make better decisions when mixing. There's not much point in buying and fitting sound-absorbing panels and other things to make your editing space sound better if the speakers you're using to listen to your mix are bad. By bad, we mean that they don't output enough of the frequency range to be able to make good mixing decisions, or maybe they have a lot of hiss or noise, or that some frequencies sound too loud compared to other frequencies. Studio monitors, on the other hand, are specifically designed to allow you to hear what's happening more clearly than a set of consumer computer speakers. There's loads of great brands of monitoring speakers out there. I've been using KRK speakers for about 2 decades now, and I think that the Rocket range are a cost-effective place to start. They come in 5, 7 and 8 inch versions and can also be paired with a KRK subwoofer so you can really hear the low end or the lower frequencies of your mixes. KRK and other brands have higher end speakers, but these can get very expensive very fast. So that brings us to the end of this module. In this module, we covered the basics of sound, including its fundamental concepts like amplitude. This is the height or strength of a sound wave. Frequency. This is the number of vibrations or cycles per second measured in hertz. And this gives us the pitch of the sound. We learn that we can measure the intensity or the loudness of a sound using decibels, or dB for short. And we learned about some of the different behaviors of sound in the real world, such as reflection, sound bouncing off of hard surfaces; absorption, this is where sound is absorbed and effectively not reflected. And we learned about the importance of room acoustics and having good quality studio monitor speakers. Hi, welcome to Module 2. In this module, we'll be getting familiar with the Fairlight page in DaVinci Resolve. The Fairlight page is where you'll spend a lot of time working with audio, whether you're editing, mixing, or sound designing. By the end of this module, you'll be comfortable navigating the interface and you'll have a good grasp on the main tools and functions you need to get started. In this module, we're going to be looking at the timeline and tracks area of the Fairlight user interface. We'll look at the mixer. We'll look at the meters. We'll look at the channel strips, which allow us to do things like alter channel volume and panning. We'll learn some basic track organization skills. We'll learn about the inspector panel. And we're going to look at some workflow tips and good practices that you can make use of in the Fairlight user interface. So here we are in DaVinci Resolve. We're currently in the edit page. Let's go and switch over to the Fairlight page. So I'm going to click on this Fairlight button at the bottom here to open up the Fairlight user interface. The first thing I'm going to do is come up to the workspace menu and I'm going to click on Reset UI Layout. This is going to get us back to the default layout for DaVinci Resolve Fairlight. Notice when I do that, we now see the user interface elements at the bottom. To get rid of that, we can come back up to Workspace and we can come down and click Full Screen Window. And this is just going to give us a little bit of extra space to work with in Resolve. The timeline at the bottom of the screen here is where you arrange your audio clips. Just like in video editing, audio clips can be placed on different audio tracks. You can use the timeline for editing, trimming, and organizing your audio. You can have multiple audio tracks where audio clips are placed, and you can see here we've got a couple of tracks, this screen scratch track and this zoom track. And there's also a special type of track here, this bus track, and we'll look at buses later in the course. By default, we get this bus 1, and this is the main audio output that will be rendered into the final video. So there's a few different things we can do in this timeline and tracks area. The first thing we can do is change tracks between mono and stereo. To do that, we're going to click on the track header area here. We'll click with the right mouse button, and we'll come down here and choose Change Track Type. Currently, this track is a mono track, meaning we just have one audio signal or one audio channel, but we can change this to stereo, or any of these other track types. At the minute, notice that in the track header we've got this 1.0. This is telling us that this is a 1-channel track. Watch what happens when we change this to stereo. You can see now that this changes to 2.0, telling us that this is a stereo track with 2 individual channels. In a stereo track, these are left and right. When it comes to dialogue tracks, we're usually going to have a mono track. So let's come back here and we'll change this back to mono. A music track, on the other hand, is usually going to be stereo. To add a new track, we can right click anywhere in one of these channel headers and come up and choose add track to add a single track. We can also add multiple tracks at the same time by clicking add tracks. Let's go and add a new stereo track. And we can see now we've got this Audio 3 stereo track. We could now use this for background music. To give this track a name, we can click up here and let's change this to music. To delete a track, we can right click on the track header and choose delete track. We can also duplicate tracks and delete any tracks that don't have any clips on them. I'm just going to choose delete track to delete the music track. We can also move tracks up and down. I'm going to right click on this zoom track and we'll choose move track up. And now this track appears above the screen scratch track. Let's go and move this back up. You can see at the minute that we've got this little M lit up in this screen scratch track. This is the mute button for this track, and every track has a mute button. When this button is turned on or lit up like it is now, any of the clips on this track won't play back. What that means is if I also mute this track and then hit play, we don't get any audio coming out. Let's go and unmute this track, and then if I hit playback now, we should hear audio in air pressure. These fluctuations, which we do. If you want to quickly mute several tracks at once, you can hold down the left mouse button and drag down through the different tracks to quickly mute, and we'll just click and drag up to unmute. Next to these mute buttons, we've got the solo buttons. If I click this, what that means is now the only audio that's going to be playing back is from this soloed track. Let's take a listen. Or sound waves travel through the air or the... You can solo multiple tracks, which means that both of these tracks will play at the same time. This is where we can talk about, which we don't actually want because this track here is a scratch track, so this should always be muted. As with the mute button, we can drag up and down on one of these buttons to quickly enable or disable solo. Okay, let's talk about the mixer next. The audio mixer is located at the bottom right-hand side of the screen here, and we can turn this on and off by clicking on this mixer button and click it again to make it visible. I'm just going to go and add a few tracks by choosing add tracks, and I'm just going to create 5 audio tracks. And now we've got more tracks, we can drag this mixer over so we can see all of the channel strips. We'll talk about channel strips in just a second. This mixer area is where you'll adjust the levels, panning and sound effects for each individual track. The mixer is crucial for balancing your audio and setting up your final mix. Each one of these vertical channel strips corresponds to one of the tracks. And you can see here the screen scratch track has this screen scratch channel strip. Let's make some space by turning that off for just a second. Next up we have the viewer, and I'm just going to drag down here to mute these 2 audio tracks. And if I play this back, you can see that the picture is playing back. So this is the picture corresponding to the audio clips that we're working with here. This vertical red bar is the playhead, and this allows us to quickly scan forwards and backwards through the timeline. If you want a bigger version of this viewer, you can click this button here, and this will pop out the viewer into a floating window, and you can resize this and position it any way you want, and this floats on top of the rest of the Fairlight user interface. To pop it back in, just click this button at the top right. Next up, we've got the meters. You can turn these off by clicking the meters button here and turn them back on again by once again clicking the meters button. The meters section is essential for monitoring your audio levels during editing and mixing. Each one of these bars is a meter, and we have one for each track. I'm going to unmute this Zoom audio track. I'm just going to play back a section and watch what happens in this meter here. Decibels, or dB for short, is a logarithmic unit used. You can see it's showing us the level as each track plays back in real time. So the meters section gives us a really quick way of visually monitoring whether any track is too loud or too quiet. Also, as part of the meters, we have this control room section. We have this TP value here. This stands for true peak. And we also have this loudness section, which is another way to measure loudness, which we'll look at later in the course. Let's open up the mixer once again and have another look at these channel strips. So each track in the timeline has a corresponding channel strip in the mixer. A channel strip gives you access to all the controls for that specific track. You can customize what you want to see in the channel strip by clicking these three dots here and then toggling these items on and off. This lets you customize what you see in the channel strips. So for example, we could show or hide the EQ section by clicking EQ and bring it back by ticking it once again. So this can be useful when you're working on smaller screens like a laptop. You can also use narrow or wide track view. So let's select small track mixer, and this just compresses everything up. Once again, if you're working on a small screen or you have a lot of tracks, this can be useful. I'm going to turn this off for now and switch back to full track mixer view. You can also hide these labels at the side by unticking show labels, but I'm going to keep these on for now because they're useful when learning Fairlight. You can see here that this pan section is actually coming off the bottom here, but you can just hover over this and use your mouse wheel to navigate up and down each channel strip item. So there's a number of things you find in a typical channel strip. The first of which is this fader. The fader is used to control the volume of the track. You can drag the fader up or down to adjust the overall volume that clips on that track will play back at. One main aspect to mixing is to set your fader levels for all the tracks so your overall mix is balanced and none of your tracks are too loud or too quiet. There's also more advanced ways to do that, which we'll look at later in the course. I'm just going to double click on this fader handle to reset it to 0. The next thing we get in a channel strip is this meter section. If I just quickly play back a section of this track and watch what happens in this zoom track channel strip to measure the intensity of sound, it's not a linear scale. You can see that this meter bar goes up and down as the sound plays back. This meter displays the volume output using RMS or root mean square using a decibel scale, and RMS meters like these give us a weighted average of the volume. It's kind of closer to the way we perceive audio. By default, these meters use the IEC 60268-18 standard. For a mono track, we get 1 meter bar here, but if we were to change this to a stereo track, now we get 2 individual meters, one for the left and one for the right side of the stereo signal. Just going to change this back to mono. So the meters here have color coded zones. Green means the low to medium zone, yellow means the moderately high zone, and red is very high. Let's play this back again to see it in action, which means that a sound at 4, and you can see that we were mostly staying in the yellow zone there. While we're playing back, there's a little line that holds briefly to help you see what the peaks are. Okay, next let's look at pan control. This is the pan control here, and this controls the stereo placement of the audio. Moving this little blue dot left and right will affect where the audio comes out. Dragging it all the way to the right, the audio will come out of the right speaker or headphone, and all the way to the left, it'll come out of the left speaker or headphone. We can double click this to open up the expanded section, and we can do the same thing by moving this dial left and right, or double click on it to reset it. We're going to look at panning in more detail later in the course, so we'll just go and close this pop-up. Each channel strip also has a mute button and a solo button. These match the mute and solo buttons on the tracks themselves. And if you come up to the Fairlight menu, you can turn on this exclusive solo mode. And what that means is that you can only ever have one track soloed. If I click S down here, watch what happens to the top solo, it automatically turns off. So you can only ever have one track soloed. Depending on your use case, you might want this behavior enabled, but because it's the default behavior to have it turned off, I'm going to untick it here. So being familiar with these controls in the channel strip is key to shaping your mix, and we're going to use this throughout the rest of the course in more detail. So there's a few ways you can customize this. You can resize the mixer section, you can turn things on or off, and you can also drag this line up or down to get more space for your tracks. As your project grows bigger, you'll probably want to organize your tracks. Here's a few tips for keeping everything in order. We already looked at track labels, and these just help you to know what kind of clips you're going to place on the track. So for example, you could have tracks labeled as dialogue or music, or even by the person talking. Naming your tracks is really crucial when you have a lot of tracks going on because it can help prevent confusion and accidental changing of the wrong track. And whatever the track name is here will also appear in the channel strip. The next thing you can do is make use of color coding. You can color code tracks, which makes visual organization easier. So for example, to color code an entire track, right click on the track header, come down to change track color, and then choose a color. Let's say orange. Now all of the clips on that track change to orange. Then you could also change all dialogue clips to maybe teal, and you can see how that makes things really easy to differentiate between the different channels. You can also see by changing the track colors, it's also changed the colors at the top of the channel strips here to match. Another way you can organize tracks is to group them together into track groups, and you can do that by opening up the groups dialog box here and then creating groups. This means you can then edit all of the controls for that group at the same time, and we'll learn how to do that later in the course too. Okay, next up we've got the inspector panel, which you can open by clicking the inspector button here. The inspector panel is where you can adjust properties of individual clips on the timeline or a track as a whole. I'm just going to zoom in a bit onto the timeline and select this clip. The inspector tells us the name of this clip, in this case M01-01 MP4, and it also gives us access to these clip level controls. You can also click this button here to switch the inspector to track level view, and any changes we make here apply to all clips on the track. Typically though, in the inspector, you're going to be working at this clip level view. So for the selected clip, we could increase the volume or decrease the volume, or click this button to reset it to the default. Being able to do this at the clip level is useful for fine-tuning the volume of specific clips without affecting the entire track. Just like the pan knob in the channel strip, you can also pan individual clips left and right and click this to reset. You also have a number of other things that you can enable or tweak for individual clips. You can turn on voice isolation to get rid of background noise when people are talking. You can use the dialogue leveler, the music remixer, and you can even change the pitch of the clip, and you can even do clip level EQ adjustments. We'll learn more about EQ later in the course too. The key thing to understand here is that the inspector can show us clip level audio settings, whereas the channel strip always shows us track level audio settings. Changes made in the channel strip here for a track will affect all clips on that track. To close the inspector, click the inspector button again. Now that you've learned the key elements of the Fairlight user interface, let's quickly go over some tips for streamlining your workflow when you're editing in the Fairlight page. The first of which is to use keyboard shortcuts. DaVinci Resolve offers a wide variety of keyboard shortcuts that can significantly speed up your workflow in the Fairlight page. So the first thing is to hit the spacebar to start playback or stop playback. This is because the decibels. You can use the J, K and L keys for sped up playback forwards and backwards. Press the L key multiple times to have forward sped up playback. Scale is based on powers of 10. And press the K key or the spacebar to stop, and press the J key to go backwards. And press the J key multiple times to speed up going backwards. If you accidentally make a mistake, you can hit Ctrl Z to undo. When it comes to the timeline here, you can hold down the Alt key and use the scroll wheel to zoom in or zoom out of the timeline. You can hold down the Shift key and use the mouse scroll wheel to increase or decrease the size of the audio tracks. And you can hold down Control and use the mouse scroll wheel to scroll the timeline left and right. You can also use these track height sliders here and also this zoom setting here. If you hit Shift and Z on the keyboard, it's going to zoom the timeline so you can see the whole thing. If you want to hear audio while you're scrolling the playhead around, hit Shift and S to turn on audio scrubbing, and hit Shift and S to turn it off. If you find yourself frequently using certain settings, you can save presets for lots of different things in Fairlight. This is great for maintaining consistency across multiple timelines or projects. To do this, you can come up to the Fairlight menu, choose Presets Library, and then choose one of the class or type of presets. So we've got equalizer presets, dynamics presets, plugin presets, global track presets, global bus presets, and Fairlight configuration presets. If you save a Fairlight configuration preset, it's going to include loads of things, including the tracks, so you can quickly get back to a starting point if you use the same configuration over and over again. I'm not going to do that here. I just wanted to show you that it's possible. So that brings us to the end of this module. We learned about the timeline and tracks area of the Fairlight page where we place our clips. We learned about the mixer where we can adjust the volume of tracks and other track level items such as panning. We learned about the meters section where we can quickly see how loud all of our tracks are. We learned about all the different things we can do in the channel strips and the fact that we have channel strip for each track. We saw some basic ways of organizing tracks, including setting a track color. And we learned about the inspector panel and how it allows us to make clip level adjustments. We looked at some basic workflow tips and good practices like using keyboard shortcuts and saving presets for things that you use quite often. Hi, welcome back to Module 3. In this module, we'll dive into one of the most important aspects of audio editing, working with audio at the clip level. So in this module, we're going to be learning about different aspects of audio clip editing, including moving clips, making clips shorter by trimming the starts and ends, changing clip volume, and as part of this, we'll learn about the 4 editing modes in Fairlight: pointer mode, range mode, focus mode, and pencil mode. We'll learn how to make clip level adjustments and work with clip level effects, and we'll also learn about audio transitions. Alright, here we are back in Fairlight. The first thing I'm going to do is come up to the top and I'm going to turn off the meters just to give us a bit more screen real estate. Let's start by learning the basic editing tools you'll use all the time to manipulate audio clips. So in Fairlight there's 4 main editing modes and you can see the buttons here to switch between them. These let you perform a variety of actions on audio clips, automation data and other elements of your timeline. The 4 editing modes are pointer mode, range mode, focus mode, and pencil mode. Let's start off with this pointer mode, and you can see at the minute it's the default mode. It's highlighted in red. Pointer mode allows you to select one or more clips by just clicking on them. If you want to select multiple clips, you can hold down the Control key. Or if you want to select a number of clips in a range of clips, select the first one, hold down the Shift key, and select the last one. You can use the pointer mode to trim the start and ends of clips. To do that, move your mouse cursor so you see this icon, hold down the left mouse button and drag to the left or the right to change the length of the clip. You can do this at the start of the clip. Let's trim the start to make the clip shorter. You can also use this line here to change the volume of the clip or double click it to reset it. To move a clip around, hold down the left mouse button and drag left or right, or down and up to move it to other audio tracks. When you're moving clips around in the Fairlight page, if you see this little red box with a value in, this means that the audio is no longer lining up to the linked video clip. If these are separate audio files, then this is not a problem, but if these clips in the edit page, I just switch back to the edit page, you can see that when I click on one of these clips, and I have this linked selection activated, it selects the other clips. So these audio clips on these 2 tracks are linked to this video clip. If I hold down the Alt key and select just one of these audio clips and move it left or right, you can see that we get this familiar red box telling us that this audio no longer lines up to its associated or linked video track. So that's just something to be aware of when you're moving clips around in the Fairlight page. Just going to use Ctrl-Z to undo that. So pointer mode here is used for general selection. You can also use it to move the playhead and drag it left and right. If you want to select all of the clips on a specific track, first click the track header. So I'm going to click the track header for zoom here, and then use Ctrl-A on the keyboard to select all of the clips on that audio track. To deselect any selected clips, use Ctrl, Shift and A on the keyboard. If you're in pointer mode and you want to split a clip in half, you can select the clip, move the playhead to where you want to cut or split the clip, and then either click on this scissor icon here. Now you can see we've got 2 clips, or select the clip, move the playhead and use Ctrl-B to cut or split the clip. Notice that when we do this, and we don't have any clips selected, if I hit Ctrl B, it's going to split all of the clips. If I wanted to cut just the top clip, what I can do is click this button here to turn off linked selection. And now when I click on any one of these clips, it won't automatically select any linked clips. So now I can move the playhead anywhere I want, select the clip, and either click the scissors tool or use Ctrl B on the keyboard. Just going to turn linked mode back on now because this helps keep everything in sync. Okay, let's move on to the second mode, and that's range mode. You can switch to range mode by clicking this button here or using R on the keyboard. And if you want to get back to pointer mode quickly, you can use A on the keyboard. So range mode is used to create time-based selections or ranges within a clip or across multiple clips, making it easy to make changes to specific sections of the timeline. So the key thing here, it's not just an entire clip, but ranges within and across clips. Just going to zoom in using Ctrl+ on the keyboard, and we'll also turn off the mixer to give us a bit of extra space. So I'm going to use Ctrl and the mouse wheel to come across here, and with range mode activated, I'm going to drag from the middle of this clip to the middle of the next clip. Notice that this creates a range. And if I zoom in, you can see we've got this green line at the top. And if you want to adjust the range, move your mouse button over the little dot at the end of this range, hold down the left mouse button, and then you can drag the range left and right to extend the end, and the same thing at the beginning. Once you've selected a range, you can use it, for example, to reduce the volume of that range. Notice it's reducing the volume of the selected range and not the entire clip. I just drag this volume line down, and we'll zoom out a little bit, switch back to pointer mode, and we'll clear this range by using Alt-X on the keyboard. Using this range mode allowed us to very quickly select a range that covered multiple clips and make changes to that range. Let's have a look at another example of the range tool in use. We'll drag a range around here, and if I hit backspace on the keyboard, it's going to remove any audio clips within that range. I'm just going to undo that. But what if I wanted to just remove the audio on this top track? To do that, I can lock the other tracks. So I'm just going to click the padlock button here on this screen system track, and once again hit the backspace key. Now you can see that it's deleted this clip here, but it's left the clip on this track unchanged. All right, let's move on to this focus mode. You can think of focus mode like a multi-tool or one of those pen knives that have a bottle opener, a knife, a pair of scissors. The benefit of using the focus mode is you can accomplish a lot without having to switch between these other modes. Let's go and find an unedited area here, and I'm going to unlock this second track. So with focus mode selected, if you click and drag at the top of a clip, you can use it to select a range, just as we did with the range mode. Just going to clear that by using Alt-X. But if I move the mouse cursor to the bottom half of a clip, notice that in focus mode it changes to this hand icon. With this hand icon, we can hold down the left mouse button and move the clip to the right or to the left. Just going to undo that with Ctrl-Z. Let's go and select another range, once again by moving the mouse cursor to the top of the clip in focus mode. And then if we move down to the bottom, this icon changes to a hand. We can very quickly cut a selection of a clip out and move it to another track. All we need to do this is hold down the left mouse button over this hand icon and drag it down. We've now cut the clips from these two original tracks and moved them down to these two new tracks. Let's go and undo that. Let's go and do that again, but this time we'll turn off the linked selection. We can drag our section, move down here so we get the hand tool, and this time if I drag down, notice we only get the one track moved because we turned off linked selection. Just as we did with the pointer tool, if we hover the mouse over the top left of a clip in focus mode, we can trim the start and we can trim the end. We can also reduce the volume of a clip and reduce just that part of the volume, and select across multiple clips and reduce volume across multiple clips. Let's just find a clean section of the timeline. In focus mode, you can create fade-ins by coming up to the top left of a clip and dragging this handle to the right, and you can create fade-outs by dragging this handle at the end to the left. If I just play this back, while we're playing back, there's a little line that holds briefly to help you see what the peaks are. The last of the 4 modes is this pencil mode, and pencil mode is used to draw automation curves directly onto the timeline. This tool gives you complete control over your audio adjustments by allowing you to sketch out custom curves. We'll look at this later in the course when we learn about automation. So just as a recap, you can switch to pointer mode by pressing A, range mode by pressing R, or use the mouse to switch to focus mode or pencil mode. Okay, now that we know how to cut and move clips, let's dive into clip level adjustments. These adjustments affect only the selected clip rather than the entire track. So let's come across here and find a unedited clip, and we'll hit A on the keyboard to switch back to pointer mode. So one of the most common adjustments you'll make at the clip level is changing the volume, and as we saw, you can do that by hovering over this volume line and dragging it down to decrease the volume and dragging it up to increase the volume. Notice that when we increase or decrease the volume, very handily the waveform gets bigger or smaller, giving us a visual indication of the volume change. You can also change the volume by selecting a clip and then coming up and opening the inspector and using the volume slider here. Watch what happens in the clip when I change this volume slider. You can hold down the left mouse button on the value and slide left and right, or double click and enter a value if you have a precise value that you need. With the inspector open and making sure you're on this clip level, not this track level, you can also alter things such as the pan. Let's play this back. Little blue dot left and right will affect this little blue dot left and right. And you can always click this button here to reset things to their defaults. You can change the pitch in both semitones and cents.
Little blue dot left and right.
And either reset things individually using these buttons or reset the entire section using this button. If you wanted to, you could also apply clip level EQ using this section here. You can use these buttons to toggle off any changes made and click them again to toggle that aspect back on. The important thing to remember is that these properties are based on a clip by clip level. They don't apply to every clip on the track. So we learned that we can drag these little handles to create fade-ins and fade-outs. But if you want to, you can also select multiple clips. Let's go and select the first clip here, hold down Shift and select this last clip, and we'll just zoom in. With multiple clips selected, you can come up to the Fairlight menu and you can choose this Apply Batch Fades option. And before you do this, you can open up the Batch Fade settings and choose what you'd like. So here we've got Fade In and Fade Out selected, and we can just quickly apply that once we've changed the settings. And you can see now that each of these clips has had this fade in and fade out applied over 30 frames. All right, let's take a look next at clip level audio effects. What I'm going to do is I'm going to find one of these clips, have one track soloed. And to make some space, I'm going to use the range mode, just drag out the section and hit backspace and then hit Alt X. And in pointer mode, we'll just move this across. Let's go and add an audio effect to this clip. To do this, you can come up to the top left and click the Effects button to open up the effects. Here we've got a list of all of the audio effects, and let's go and add an echo effect to this clip. I'm going to drag this echo effect over and release the mouse button on top of this clip, and then we get the effect pop up, allowing us to change the effect settings. So this will look different depending on the effect that you've dragged across. Let's just play this back with the default settings, depending on your use case. And you can hear that echoing, depending on your use case. But notice that the echo effect stops as soon as the clip ends. One way to fix this is to trim the end of the clip, use the focus mode tool, select a range, and just reduce the volume for that range down to 0. Let's have a listen now. Depending on your use case, you can hear the echo continues now. Let's go and make this echo even bigger. Depending on your use case. And you can alter things like the delay time and the feedback and the dry wet, depending on your use case. So it really echoes for a long time. If you didn't want to extend the clip, so what I'm going to do is I'm just going to trim it back to here, and we'll play this back again, depending on your use case. And once again, the echo is abruptly ending. Another thing you can do is select the clip, and in the effects menu here on these 3 dots, click it and enable bounce tail. Then click these dots again and choose bounce audio effect. This is going to apply the audio effect and then create a brand new audio file. You can see down here that this audio file has been created for us by Resolve, and if I play this back now, it's going to have that effect baked into it. Depending on your use case, you might want this. The side benefit of doing this is that you're bouncing the effect right into this audio file, so it can reduce a bit of load on the system if the audio effect you're using is quite CPU intensive. The disadvantage of this approach is that you can't quickly alter the effect settings. Okay, let's talk next about audio transitions. Sometimes you'll want your cuts or your edits where one audio clip goes straight into another audio clip to feel smoother and more natural. This is where audio transitions come in, specifically crossfades. You might also hear the term audio dissolve. Let's scroll across here. I'm just going to close the effects and we'll switch to pointer mode and zoom in here. What I'm going to do is trim the end of this and we'll move this across the wrong track and whatever. And now what we can do is right click on the join between these two clips and we can quickly add a crossfade. A 2-frame crossfade is really quick and a 20-frame crossfade is a bit wider. So let's click on add 20-frame crossfade 0 dB. Now we get this section here. This is telling us that the audio is cross-fading. Essentially what this means is that this first clip will fade out while the second clip is fading in. Let's have a listen to this. Of the wrong track and whatever the track name. If you want to alter the length of this crossfade, move your mouse so you see this icon here and drag the left or the right. You can also drag this point here to alter exactly how the crossfade behaves. An accidental changing of the wrong and whatever the track. If you open up the inspector and make sure that the transition is selected, notice that this transition section in the inspector is now enabled and we can change the type of crossfade. We can change where this happens, at the end of the first clip, at the start of the second clip, or in the middle of the two, and drag these things to change the duration in frames or in seconds. So if you ever find yourself with two audio clips next to each other, but when they play back, you hear a click or some kind of annoying audio, a crossfade can often help eliminate that and just make the transition or the two clips sound much better when they're next to each other. If you want to delete the transition, you can just select it and hit backspace on the keyboard. Another way you can add a crossfade is by once again opening up the effects by clicking this button, making sure you're on the audio transition section, and then dragging the crossfade of your choice over the edit point between two clips. And then you can adjust it as required. And I just want to tell you about one quick gotcha. If you find yourself trying to apply a crossfade and it's just not working, or perhaps you can only apply it to the start or the end of a clip, it can mean that you don't have enough crossover room on the clip. I'm going to show you a quick example of this just so you know what's happening, because it can be quite frustrating. What I'm going to do is I'm going to drag out this audio clip right to the end, and notice how Fairlight really helpfully tells us how much audio data we've got as we're dragging to the right. I can't drag any more to the right because that's the end of the audio file, and we'll just move this down here to audio track 3, and I'm going to right click. I'm going to change this individual clip color to orange. I'm then going to use Shift Z on the keyboard and we'll move this all the way to near the start. I'm going to hit home on the keyboard to go to the start, or to move the playhead to the start, and use Ctrl+ to zoom in. I'm then going to grab this first audio clip and move it down here, but I'm going to expand this across all the way to the start. So I can't go any more here. This means that this is the start of the audio file. What I'm going to do is drag this across and I'm going to put it after this file. So there's no more audio data after this orange file, and let's change this to teal, and there's no more audio data before this. If I right click on this join and try and add a crossfade, notice it's going to tell us that some of the selected clips have insufficient handles, and handles just means extra audio data outside of the audio data that we're actually using. So we can go and trim the clips to create handles, or we can skip clips or just hit cancel. So let's go and create some handle data or handle space by moving this to create some space before and then moving it back up to join. If I right click now and choose add crossframe, it's going to give us the same message. That's because we don't have any handles on this first clip. But if I trim the end of this and then move it up, right click again, we should now be able to add a crossfade, which we can. So just make sure that you've got sufficient space before or after the clip starts or ends to be able to apply a crossfade. So that brings us to the end of this module. In this module, we learned a number of different ways we can work with audio clip editing. We learned how to move clips around, trim the start and ends of clips, change clip volumes, and as part of this, we also learned about the 4 editing modes. Pointer mode, which is the default mode in Fairlight, and it allows you to select clips, move clips around, trim the start and end of clips, and change clip volumes. We learned about the range mode and how we can use the range mode to create time-based selections or ranges either within one clip or across multiple clips, and this can make it easy to make changes specific to a section of the timeline and not just one clip, such as altering a volume range over multiple clips. We saw the focus mode tool, and we learned that this is like a multi-tool that allows us to do lots of different things without changing to other tools. And to use the focus mode tool, we can hover the mouse button over the top of a clip to mark ranges and hover over the bottom of a clip to select a clip or move it around. We also learned a really cool feature where we can select a range and then drag it down to create 2 cuts and move that section to another audio track. The 4th mode is pencil mode. We can use this to draw automation, and we'll use this later in the course. We learned about clip level adjustments, such as adjusting the clip volume or panning, and clip level effects, such as applying an echo effect to a specific single clip. Finally, we saw audio transitions in use, specifically the crossfade, which allows us to smooth out the transition between 2 adjacent audio clips. While clip level adjustments impact individual clips, track level adjustments affect the entire audio track and therefore affect any clips that are placed on that track. In this module, we're going to start off by looking at the track level volume controls. This controls how loud or quiet the playback will be for that track. We'll also look at track panning to determine which speakers the sound will come out of, and we'll learn about track dynamics. When it comes to working with track dynamics, we're all about controlling the dynamic range of anything playing back on that track. And recall from earlier in the course, we learned that dynamic range essentially means the difference between the quietest and loudest point. As part of controlling track dynamics, we're going to learn about the compressor, the limiter, the expander, and the gate. In addition to volume, panning, and dynamics, we can also use the track equalization tool, or EQ for short, to control the various frequencies that are being played back on that track. In this module, we'll also look at a few track level effects, such as the voice isolation tool, the noise reduction tool, and a limiter that we can place on a bus to further help us control the dynamic range. Here we are back in Fairlight. Let's go and open up the mixer. The first thing we're going to look at is altering the track level volume by using the fader controls. To increase the volume of a track, you can move the fader up, and to decrease it, you can move it down. To reset it to 0, double-click the fader handle, and it will return to 0. As you're moving the fader up and down, you can see this number here increasing or decreasing. A positive number means it's going to be louder than the default, and a negative number means it's going to be quieter than the default. Remember that this is a decibel scale, so it's not a linear scale. If you want to make more fine-tuned adjustments while moving this slider up and down, simply hold down the Shift key, and now you can move in 0.1 decibel increments really easily. You can also click on one of the track headers here and open up the inspector, making sure that you're on this track level view, and adjust the volume using this slider here. As I'm moving this slider, watch what happens down here in the channel strip. It's moving the same way. Let me show you this in action, and I'm going to play back a section while adjusting the fader. You can use the pointer mode to trim the start and ends of clips. To do that, so you see this icon. Hold down the left mouse button and drag to the left. The next big track level thing you can change is panning. So you can just move this dot left and right to adjust which speaker the sound comes out of. Let me show you this during playback. So you see this icon. Hold down the left mouse button and drag to the left. And you can double click on this panning section to open up more detailed controls. As I move this control here, you can see the blue dot in the main window move, and also the blue dot in the channel strip move. This blue dot represents where in the stereo field the sound is going to come out of. And if you double click this dial, it will reset to the middle, and that's what this C means here. We'll look at some of these other controls later in the course. By adjusting track level panning, you can create stereo width and balance during mixing. So this means you can create space for different audio elements to sit in the stereo field, basically so you can hear them. You can even automate panning to create immersive audio like a car driving by from left to right. We'll learn how to use this panning control to mix elements together later in the course. For now, I'm just going to close it. The next major tool we have when we're working at the track level are the track level dynamics controls, and this line here represents a visual indication of what we've got set up, and we can double click this square to open up the dynamics controls. We can enable or disable the hold dynamics control by clicking this toggle button here, and when we do this, look what happens in the channel strip. This line goes grey, telling us that the dynamics are bypassed or disabled, and we can turn it back on, and that line goes back to green. So dynamics processing is all about controlling the dynamic range of audio. If you have someone whispering, then shouting really loud, that means a larger dynamic range. If you have someone whispering and then talking normally, not shouting, then the dynamic range is not as large. All of the controls inside this dynamics tool allow us to control or shape the dynamic range. And this dynamics dialog box essentially gives us access to 4 different tools. We can toggle these on separately using these toggle switches. So let's start off by looking at this compressor section, and we'll go and turn it on. A compressor allows us to reduce the dynamic range by reducing the volume if it gets too loud. Let's take a look at some of these controls. First of all, we've got this threshold control, and when we move this, you can see the blue vertical line moves in the display. The threshold setting allows us to tell the compressor the level that we think is too loud. When the incoming audio goes over this volume threshold level, that's when it starts to be made quieter. Next up, we've got this ratio setting, and you can see as I alter this, it alters the line after the blue threshold line. How quieter it gets, or the amount of gain reduction, is controlled by this ratio. Or in other words, it allows us to adjust the compression ratio applied to signals over the threshold. The bigger this ratio, the more compression will be applied and the more unnatural it can sound. For dialogue, we're normally going to keep this on the lower end because we want speech to sound natural. So for example, if we were to set this ratio to 3:1, it means for every 3 decibels of volume the signal goes above the threshold, only 1 decibel of volume will actually be output. Next up, we've got this knee control, and watch what happens when I adjust this. It's altering the shape of the green line around the threshold line. The knee setting controls the smoothness of when compression starts. 0 is called a hard knee. This means that compression kicks in directly above the threshold value, but increasing the knee value creates a softer knee. This means compression gradually turns on as the incoming signal approaches the threshold and rises above it. A soft knee makes compression less noticeable and less harsh. The next control is this mix control, and this allows us to mix in a little bit of the original uncompressed signal if you want to retain a bit of character of the original sound. A lot of the time, you'll leave this set to 0. This attack knob sets how quickly the compressor reacts to signals when they go over the set threshold. A very short attack time means that compression will take place really quickly after the level exceeds this blue line, and a longer attack time means it'll take longer for the compression to start happening. Next is this hold control. This hold setting is applied after the attack phase, and hold controls how long the initial attenuation or reduction is held for. And the release knob here controls the release phase, which happens when the hold phase finishes, and it adjusts how slow or how fast the sidechain stops applying compression, and we'll talk about sidechains in a later module. So that's the compressor. Let's go and turn on the limiter next. When we turn this on and off, we get this horizontal blue bar. A limiter is kind of like a compressor, but it has a really high fixed compression ratio. You can use it to set a maximum signal level that you don't want the sound to go over. And as I change this, you can see the horizontal blue bar go up and down, and we can use it to set a maximum signal level that we want coming out of this dynamics control. There's also a plug-in effect limiter, which we'll look at in just a minute. Just like the compressor, the limiter has a attack setting, a hold setting, and a release setting. Next up, we've got the expander. I'm just going to toggle this section on. And an expander is the opposite of a compressor. We can use it to increase the dynamic range. An expander does this by lowering the volume of lower parts of the signal when they fall under the expander threshold, which is this control here. And you can see we've got this additional vertical line here showing us the expander threshold. So the threshold is the level under which expansion happens. The range control controls how much of the signal level will drop, or in other words, the amount of decrease in signal level. The ratio sets the attenuation ratio, like the compressor has a ratio, controls the rate at which signals will drop. And like the compressor, we have the attack setting, which adjusts how quickly the expansion occurs when a signal exceeds the threshold. We also have the hold setting, which is how long the expander is kept open for when the input signal falls below the threshold, and the release setting, how fast or slow the expansion goes away when the input signal goes back below the threshold. As well as being able to use the expander, we can also use the gate by clicking the gate button. And a gate is different from an expander because it reduces the output level or even completely silences it when it falls below the set threshold level here. You can use a gate to reduce or eliminate noise in quiet parts of a recording. The threshold sets the level below which the gate kicks in and the gain reduction starts to happen. So if you move this all the way to the left, it will affect only the quietest of signals, but as you increase this, it will also affect louder signals. Range specifies the maximum amount of gain reduction applied when the input falls below the threshold. And if we try and move this knob, you can see that ratio is not used for the gate control, but we can set the attack, which is how quickly the gating occurs when the input exceeds the threshold. As with the other controls, we have the hold value, which keeps the gate from being triggered again until a certain amount of time has passed. And the release control allows us to set how quickly or gradually the sidechain detector works. So I'm just going to turn off these two sections here and just leave the compressor enabled. So now we've just got the compressor turned on, and I'm going to start playback, and I want you to watch what happens in the compressor control here. If you want to select a number of clips in a range of clips, select the first one, hold down the shift. You can see this middle bar here is showing us the amount of gain reduction that is being applied, or in other words, the amount of compression that's happening. The bigger this bar goes down, the more compression we're adding. This bar here shows us a meter for the expander or the gate, and this bar here shows us the limiter gain reduction meter. When it comes to this big square in the middle, the x-axis, the horizontal axis, represents the incoming signal level. The y-axis, the vertical axis, represents the output level, and this green line represents the dynamics curve, which shows us the compressor and the knee. Let's play this back. You can see these light green balls showing us how the dynamics control is affecting the signal. The smaller lines on the X and Y axes here show us exactly what the input and output levels are. One useful thing that a lot of these controls share is this A and B section. This allows us to compare two different versions of the tool's settings. So let's go and have version A here set to a really low threshold, and if we play this back, you can see we get a lot of gain reduction happening because that threshold is really low. And maybe we want to compare this with another version. I'm going to copy the settings from A to B using this button here. I'm going to switch over to B, and then we can adjust the threshold. What I can do now is play back and switch between those two different versions. We've also got a number of useful presets here that come with DaVinci Resolve, such as this dialogue compression preset. If I click that, it's going to set not only the threshold, but these other controls as well. You will still need to adjust the threshold depending on the level of the incoming signal. The final thing we can look at here is this makeup gain control. This allows us to boost the volume if it's being reduced by the compressor. So if we've got really heavy compression that's really reducing the volume, we can increase this to get the overall level similar to when it came into the dynamics control. Also notice in the channel strip that we've got the threshold line showing now for the compressor that we set in this mini representation of the graph. The next major tool we're going to look at is the equalization or EQ tool, which we can access by double-clicking on this section here to open up the EQ controls. The EQ allows us to control the volume of different frequencies within the channel. EQ is all about reducing the frequencies that make things harder to hear or sound more unpleasant, and also increasing the volume of other frequencies to make things easier or more pleasant to listen to. Increasing volume of a frequency is known as boost or boosting, and decreasing volume of a frequency is known as attenuating. The first setting we can look at here is this equalizer type, and this changes the shape of the curves that we can create in the EQ control. Earth sets the EQ to use the native Fairlight EQ response curves, and the others represent emulations of classic mixing hardware console EQs. Let's just go and grab this band, and I'll explain what these do in just a second, and we'll go and create a curve here and another one here. Watch what happens when I change between these different equalizer types. The shapes of these curves change. Also, when we switch to fire mode, watch what happens at the bottom left and right here. We get these additional Q factor controls. So which one of these should you choose? If you're just starting to learn EQ, then just leave it set to a specific one the whole time, and when you get more experienced and your ears get more trained on audio editing, you can try the other ones to see which ones sound best for the mix you're working with. So let's just stick with fire. The EQ control in Fairlight allows us to specify 6 individual bands in which we can alter frequencies. We can toggle each band on and off by clicking the relevant band number, and when a band is lit up in red, it means it's active, and we also get the band number on the chart. The frequency control affects the frequencies at which the band will operate around. We've also got the L, ML, MH and H buttons, which allow us to control different ranges of the frequency spectrum. L is for low frequencies, ML is for mid-low frequencies, MH is for mid-high frequencies, and H is for high frequencies. And you can also drag these individual band numbers left and right, and as you do that, it will automatically change from L to ML to MH to H. You can also hold down the Shift key while dragging this to make fine-tuned adjustments, or double-click on the frequency to actually type in a frequency. The gain control, if it's set to a positive value, will boost frequencies controlled by that band, and if you set a negative value for gain, it's going to attenuate those frequencies. This is a value in decibels. You can also hold down Shift while you drag this control to make fine-tune adjustments, and as with frequencies, you can double-click to set a specific value. The Q factor here allows us to specify how narrow or wide a set of frequencies will be affected, or in other words, the bandwidth of the affected frequencies. A very high Q factor will mean that only a small range of frequencies will be affected, and a very low Q factor will affect a wide range of frequencies around the set frequency value. Bands 2, 3, 4 and 5 allow us to set 4 different band types, which we can access with these drop-down menus. We have the bell band type. I'll just turn these other ones off for now. And as the name suggests, the bell creates a bell-shaped curve. We have the notch by clicking this button here. A notch gives us really narrow access to a frequency band if we're really trying to cut out a problematic frequency. It's like a surgical cutting tool for a specific frequency. We also have the low frequency shelf. This allows us to affect all of the frequencies below a specific frequency setting, either positively or negatively. You can see it creates this kind of shelf curve. And we also have the opposite to this, the high frequency shelf, which will boost or attenuate signals above a certain frequency. Let's turn on band 1 now. Band 1 is all about the lowest frequencies of the audio. By default, it's set to this shape here. This is called a high pass or sometimes a low cut filter. What this does is it reduces the volume or attenuates frequencies lower than the set frequency value, and it lets higher ones pass. We can also select the slopes here from 6 to 24, and you can see how this affects the shape of the curve. These slope settings allow us to specify how quickly frequencies get affected once they get below the frequency setting. In band 1, we also have this slope. This is the high shelf, and you can see we can adjust frequencies above the set frequency. We can either boost them or attenuate them, and the opposite to that is this setting. This is the low shelf. And finally, we have this one. This gives us a bell shape. At the other end of the scale, we've got band 6. Band 6 is focused on the highest frequencies of the audio. If I adjust the frequency, you can see by default, this is set to a low pass filter, sometimes called a high cut filter, and this reduces the higher frequencies in the mix and lets lower ones pass by. And we've also got selectable slopes here. 6 decibels an octave, all the way through to 24 decibels an octave. Again, this is how quickly frequencies get affected. We've also got the high shelf, the low shelf, and the bell. The master gain control allows you to boost the output from the EQ. If you've attenuated a lot of frequencies and it's reduced the overall volume, you can use this to kind of balance things out. You can also set it to a negative value if you've boosted frequencies. And as a bonus tip, if the band has a Q value, you can hover the mouse over it and use the mouse wheel. And you can see down here the Q factor is changing by just using the mouse wheel hovering over the band number. Just going to turn this off, and we're going to play back a section here and watch what happens in the EQ. Move your mouse cursor so you see this icon. You can see the different frequencies coming into the EQ. On the left here are the lower frequencies in hertz, and on the right here are the higher frequencies. And you can see down here 16K is short for 16 kilohertz. I'm going to play this back again, and I'm going to make some EQ changes. The frequencies or the audio coming in you'll see in lighter blue, and the frequencies going out will be in darker blue. So let's just play this back. Drag to the left or the right to change the length of the clip. You can do this at the start of the clip. Let's trim the start to make the clip shorter. You can also use this line here to change the volume. You can see down here is the original signal, and this line here is the new signal. To reset the EQ, you can click this button here. Some general advice when working with an EQ is that when boosting signals or making frequencies louder, we want to use a wider Q factor, and when cutting frequencies or attenuating frequencies, we want to use a narrower Q factor. We'll see EQ in action later in this course when it comes to mixing sounds together. Okay, let's take a look at some effects now. The first effect we're going to look at is this voice isolation effect. You can turn this on by clicking this little round button here, and it's going to turn red when you hover over it, and the effect turns yellow to tell us that it's activated. To open up the controls for the voice isolator, click this little tiny button here, and this will open up the control for the voice isolation. This is a very simple control. We've just got one knob which allows us to specify the amount of voice isolation. This effect allows us to enhance the clarity of dialogue or spoken word, and under the covers it uses the AI features or the neural engine feature of DaVinci Resolve to try and do that. So I'm going to play back a section. It's highlighted in red here. Pointer mode allows you to select one or more clips by just clicking on them. If you want to select multiple clips, you can hold down the control key. And you can hear there that it's trying to reduce any background noise, and it's also trying to improve the clarity of the talking by reducing some of that background reverb. This tool is only available in the studio version. You can turn this effect on or off with this toggle button, and when I do this, watch what's happening in the channel strip. It turns from yellow to grey to indicate that it's turned off or bypassed. The next effect we're going to look at is the noise reduction effect. You can add one or more effects to each of these channel strips by clicking the plus button next to effects, and then choosing from all of these different categories. So there's a lot of different things that come bundled with DaVinci Resolve. We're going to look in this restoration section, and we're going to choose this noise reduction plugin. When we add a new plugin, it's automatically going to open up the controls for that plugin. This noise reduction plugin allows us to clean up background noise in audio. You can use one of the presets here, or you can actually ask this noise reduction plugin to learn from the audio that's being played back. So what I'm going to do is I'm going to switch to the focus mode. I'm just going to drag a little section. I'm going to make sure loop playback is on, and then if we play back there, it's just going to loop around this section. I'm then going to click this learn button. It turns red to tell us that we're in learning mode, and then I'm going to hit playback. By doing this, the noise reduction plugin has learned or trained itself, and we're telling it that the audio playback that was playing back while the learn button was clicked is the kind of noise that we want to reduce. Just going to close this for now and hit Alt-X to deselect the ins and outs. We could have a whole course dedicated to the plugins that are available in DaVinci Resolve, and that course would probably be 20 hours long. But I just want to show you one more really useful plugin. Notice that on the bus, we can also add effects. I'm going to click the plus button, and then I'm going to come down to Dynamics, and I'm going to choose Limiter. A limiter detects and reduces peaks in volume, so the overall level can be increased without clipping or maxing out the signal. Effectively, it's reducing the dynamic range in a similar way to the compressor we saw earlier. When you add this limiter effect as a plugin, it acts as a true peak limiter that looks ahead 64 samples of the audio that's coming up, and it does this to try and create a smooth limiting effect. We'll look at limiting in more detail later in the course. The last thing I wanted to show you about these track level adjustments is this order section here. Each of the audio channels has this order section, and it allows us to choose the order in which things are processed. By default, you can see here that it's FX, DY, EQ. That means that the audio signal coming from the clips on this track are first going to go through the effects, and after they've been through the effects, they'll go through the dynamics, and after they've been through the dynamics, they'll go through the EQ. If you click on this for a channel, you can specify the order that you want. For example, you might want the EQ to happen first, then the effects, and then the dynamics, and you can click on this to change the order. In this course, we're going to be leaving it as the default effects, dynamics, EQ, signal chain. So that brings us to the end of this module. In this module, we learned how to set the track volume using the faders. We learned how to set which speakers the signal comes out of with track panning. And we learned about the 4 aspects of the track dynamics control: the compressor, the limiter, the expander, and the gate. We then learned about track equalization and how we get 6 bands we can use to adjust the relative loudness of different frequencies in the track. And we saw some examples of track level effects, such as the voice isolation effect, which tries to remove background noise from dialogue, the noise reduction effect, which we can train to reduce certain types of noise, and adding the limiter effect on a bus to help us control the overall dynamic range. So to summarize, track level adjustments are great for wider or more broad changes that apply to all clips on a track, whereas clip level adjustments allow for a more precise control over the audio in a single clip. We use track level adjustments for overall mix changes and clip level adjustments when you need to work on focused individual specific elements. Automation allows us to change the value of audio parameters like volume, panning, and effect settings over time. This means we can have different settings for different parts of the timeline. Automation is a super powerful thing to understand because it really allows you to fine-tune your mix. In this module, we're going to start off by looking at the difference between track level versus clip level automation and when you might want to use one versus the other. And then we'll dive into clip level automation. And to do this, we'll see how we can automate the clip volume over time. We'll do this by manually adding keyframes, and then we'll look at track level automation. When it comes to track level automation, we can manually add keyframes just like with clip level automation, and we can also use the pencil tool to draw curves over time. When it comes to track level automation, we can also record it in real time. What this means is that we can have the timeline playing back and be adjusting controls in real time to respond to what we're hearing, and these changes get recorded as automation. So we can think of automation creation as falling into 2 basic camps. Manually created automation. This is where we're drawing or creating the automation keyframes in advance and then listening back to it to see if it sounds good or not. And if it doesn't, Then we can go and manually alter the keyframes, play it back again until we get the sound that we're looking for. Recorded automation allows us to really use our human creativity in the moment to change things as we're recording the automation in real time. We can of course go back and modify the recorded automation to tweak things further. When it comes to clip level versus track level automation, there's a few key differences. With track level automation, it affects all of the clips on that track, whereas clip level automation affects only one selected clip, or in other words, the clip that you've added the automation to. We can use track level automation for global track parameters such as volume and panning, and also the properties of effects. We use clip level adjustments when we really want to target the adjustment to a specific clip's property to tweak it in a really more surgical way. An example of track level automation is altering the volume for different parts of the program across multiple clips. So you could create a long fade out across multiple clips using track level automation. An example of clip level automation might be to fade in just one single clip and maybe pan it to the left. Here we are back in DaVinci Resolve. Let's start by looking at clip level automation. So we're going to go and start by automating the clip volume level. We're going to do this by adding some keyframes. What I'm going to do is I'm just going to use Ctrl+ on the keyboard to zoom in on this specific clip. And to make things clearer, I'm going to change this clip color to orange. We can use the pointer mode that we discussed earlier to add keyframes. To add a keyframe to the volume line, which is this line here for a clip, you can hold down the Alt key, hover over this line, and you get this plus icon. Then you can left click to add a keyframe. Let's go and add another keyframe in the middle, once again by holding down Alt and clicking, and another one at the end. If I drag this center keyframe down, it's going to lower the volume as the clip plays towards the middle and then raise it back up towards the end. Let's have a listen to this. Hi, welcome back to Module 3. One of the most important aspects of audio editing. Let's just hit home to go to the start of the timeline, and I'm going to go and open up the inspector. I'm going to play this back again and watch what happens here in the volume section for this clip. Hi, welcome back to Module 3. You can see the volume level is going down. Aspects of audio editing work, and then it comes back up towards the end. And also if we scrub through the timeline, we can see the clip level automation happening for the volume parameter. We can also work with keyframes using range mode, so let's go and switch to that. I'm just going to close the inspector to give us a bit more space. Another tip when you're manually working with keyframes is to make the height of the track you're working in bigger, just to make things easier. So we're in range mode, and we can once again hold down the Alt key, hover over the volume line and click to add a keyframe. When we're in range mode, we can drag a section of the clip, hover over the volume line, hold down the left mouse button and drag up or down to increase or decrease the level of that section of the clip. But notice the existing keyframes that we added within that range are also moving relatively to the edges of the range that are moving up and down. I'm going to clear the range by hitting Alt-X on the keyboard. We can also click at the bottom of this clip to highlight the entire clip, and with the entire clip selected, hover over the volume line and drag up and down, and this will increase all of the keyframes for that clip, and we can click off to deselect. We can delete keyframes by clicking on them once and then hitting backspace. You can also do this in pointer mode. And if you want to, you can select multiple keyframes. When you select a keyframe, it turns red. And if you hold down the Control key, you can select multiple keyframes. Here we've got 2 selected in red. And if we hit backspace, we can delete both of those keyframes. You can also work with keyframe automation in focus mode. So let's go and switch to that. In focus mode, we can hold down Alt and add keyframes just as we did before, and move them up or down and left and right. As before, we can click at the bottom of the clip and move all of the keyframes for that clip up or down by the same amount. Or we can drag the focus tool selection over a number of keyframes and move that section up or down, which will also move any keyframes inside that section up or down. In pointer, range and focus modes, you can quickly remove a keyframe. To do this, you can hold down Control and Alt and then click a keyframe to remove it. and if we hover over it, we get this little negative icon, and if I click now, the keyframe gets removed, and on a Mac, this would be Command-Option-Click. If you wanted to reset the clip level automation for a clip, first of all, select the clip, open the inspector, and for the parameter that you've got automation for, you can click this little reset button. Another way to know you've got clip level automation is if you see red dots. These red dots represent the fact that the playhead is currently on a keyframe. If I move the playhead to the middle here where there's no keyframe, this dot turns grey, and you can quickly navigate between keyframes using the left and the right arrows. Let's go and reset the volume automation by clicking this button, closing the inspector, and now you can see we've no longer got any keyframes or any volume clip level automation. Just going to zoom out a little bit and just make some space here. Let's go and select range mode, and I'm going to drag a range over 2 clips. We can then grab the volume bar and drag it down, and this is going to create keyframes for us. So you can see we've got 2 keyframes in the orange clip and 2 keyframes in the green clip that follows it. But this is still clip level automation. These keyframes belong to these individual clips, and if we go and move this across, you can see these keyframes stay with the clip. Even though we dragged a range over 2 clips, which allows us to create keyframes over multiple clips, those keyframes belong to these individual clips. Let's go and select these 2 clips, open the inspector and hit the reset button to clear automation for those 2 selected clips. Let me show you another example of clip level automation. So let's go and automate the panning for this orange clip. So I'm going to hit the up arrow on the keyboard to go to the start of this clip, and we'll open up the inspector. We'll select the clip, and any of these properties that have this little diamond symbol can be automated. Notice that we can't automate the pitch, semitones or cents because there's no diamond here, but we can automate the pan because we have this diamond. What I'm going to do is I'm going to click this diamond. Now it turns red, indicating that we've got a keyframe for panning, and I'm going to drag this all the way to the left. I'm just going to zoom out, press the down arrow to move all the way to the end of the clip, and then because we've already added a keyframe for this parameter, I can simply change the value and it will automatically add this keyframe. If I hit this left button, it goes to the previous keyframe, which in this case is at the start of the clip. And if I hit the right arrow, it will go to the next keyframe, which just happens to be at the end of the clip. If I scroll through this clip, watch what's happening in the pan control. We've now got keyframes for the panning. And if I play this back.
Hi, welcome back to Module 3. In this module, we'll dive into one of the most important aspects of audio editing.
You can hear that panning automation in action. Let's go and clear that automation and close the inspector. Okay, let's take a look next at track level automation. And this is a little bit more complicated than clip level automation, but it's very powerful. You can draw track level automation or record it in real time. We'll look at recording in just a moment. Let's start off with drawing automation. I'm just going to go and undo all of these changes to get us back to our starting setup. There's 2 main views in Fairlight. Clip editing view is the default, and it's what we've been using so far in this course. Clip editing view focuses on clip selection, clip movement and manipulation, and clip level automation like the volume line we just automated. Track automation view, however, hides the volume line and shows us instead a line that represents automation values of a parameter that belongs to the entire track, such as the fader level. This automation line will affect the sound of all clips placed on that track. To switch to track automation view, the first thing you need to do is make sure that this toggle is turned on. This is the toggle automation button. Currently it's on because it's red, and if we click it, it turns off and goes grey. There's a couple of side effects of turning this on. I'm just going to click on it and watch what happens down here. When we toggle automation on, we also get the buses visible in the tracks. Also, let me go and do that again. When we toggle automation on, watch what happens here. We now get this drop down. And this drop down allows us to select which track level value we want to automate. The reason we get the buses shown when we toggle automation on is that buses also have parameters that we can automate over time, such as the fader level. The next thing we need to do once we've toggled on automation is choose the parameter that we want to add automation for. So in this case, let's choose fader level and watch what happens when I click this. We've now switched from clip editing view to track automation view. Track automation view hides the clip, gain or volume lines for the individual clips. But notice now if I zoom to fit the timeline, we've got this single line that runs across the top of all of these clips. Because we've selected fader level for the automation parameter, this line represents the fader level for this track. You can also see when we're in track automation view that the clips get grayed out or reduced in saturation a little bit. And this is another way to know that we're no longer in clip editing view. We can still move clips around and also access and change their properties in the inspector when we're in track automation view, but this is not really the main use case. At the moment, this fader level automation line is grey, which means it has no automation data for it. It will turn green when we start to add automation data. Just as an aside, Fairlight keyframes are audio sample accurate, whereas edit and cut page are only frame accurate. This means Fairlight keyframes can be placed at any sample location with sub-millisecond precision. The focus mode tool is a great choice for working with track level automation. So now we're in focus mode. To add a keyframe, just as we did with clip level automation, we can hold down the Alt key and left click to add some keyframes. Notice as soon as I added the first keyframe, this line has now turned green. Also, if I open up the mixer, notice that the fader control for this track has also turned green. This lets us know that this parameter is being automated. At the minute, we've added 3 keyframes, but they all have the same value. Let's hover over the start tier and move this line up. I'm going to hit playback in a second, and while it's playing back, I want you to notice what happens in the fader here.
Hi, welcome back to Module 3. In this module,
you can see that the fader reduced in volume following this green keyframe line. If we wanted to modify a section of a clip, we can highlight a section at the top and grab the automation line and move it up or down. To delete a keyframe, we can hold down Ctrl and Alt and then click on the keyframe. So let's go and also create a little increase in the volume here and hit Alt X to deselect everything. If you click inside this track over one of the clips and use Ctrl A, it's going to select all the automation for that track. You can then move all of the automation for the entire track up or down, and you can see it's moving the starting keyframes up and down, and you can hit the delete key to delete all of the keyframes. Notice now, because we have no keyframes for this parameter, the line has turned from green to grey. The fader knob has turned from green to grey. But here's one little gotcha if you're deleting keyframes this way. You want to go and double check the parameter. Notice that the fader value has been set to +1, so we need to reset that to the default by double clicking. Just going to zoom back in, and we'll go and highlight a section. So when you're making changes to keyframe values, we get 2 values. The first value on the left here is the new absolute value that is being set, and the value on the right in these parentheses is the delta or difference from the current value. Because we started at 0 decibels for this fader, both of these values are the same. If I let go of the mouse button and then make a further change, the absolute value is 4.5 decibels, but if I increase this, we can see that the relative value is telling us that it's being increased by 1.6 decibels from the previous value, and if I lower this down, you can see it's telling us that we've decreased the value by 2.9 decibels from the previously set value. If I'm just moving this up and down, it can be quite difficult sometimes to get the exact value that you want. If you hold down the Shift key while you're changing automation data, it allows you to move in finer tuned increments. In this case, increments of 0.1 decibels at a time. Earlier in the course, we looked at the 4 modes: pointer mode, range mode, focus mode, And we mentioned this pencil mode, but I promised you we'd look into it in more detail, which we're going to do now. So I'm going to switch over to pencil mode by clicking on it. So when we add keyframes, Fairlight will gradually alter the parameter values between the two values of the two keyframes, but we can also draw more freeform automation using this pencil tool. So let's go and automate a different parameter. I'm going to come over to the left, and let's say we want to automate the left and right panning parameter. Just going to click on that. This line is grey because we don't have any automation data for the left-right panning, and this line represents the left and right side of the stereo field. The top represents all the way to the left, and the bottom represents all the way to the right. The middle represents center panning. If I double-click to open up the panning controls for this track and just move it over a little bit, notice at the minute the left-right panning control is not green, and this is a way we can know that we don't have any track level automation. So with pencil mode selected, let's go and draw some automation data. I'm going to hold down the left mouse button and draw a curve first all the way to the top, then all the way to the bottom, then all the way to the top, and then all the way to the middle. The first thing to notice is that the panning control now has this green light underneath it, telling us that we've got automation data for it. And if I move this out of the way, this line has now turned green, showing us that it's got automation data. I'm just going to play this back and watch what happens to this panning control, and also listen to the panning effect.
Hi, welcome back to Module 3. In this module, we'll dive into one of the most important aspects of audio editing, working with audio.
There's also a shortcut to using the pencil tool. If you're in the focus mode, you can temporarily enter pencil mode by holding down Alt and Shift and then drawing automation data. Let's just close the panning controls. We'll click here, select Control A, and then hit the delete key. As before, notice that the line is not centered anymore. So without adding keyframes, we can reset this to center panning. To automate effects plugins, first you need to add one to the track. Let's go and use bus 1, but this will also work for audio tracks, not just bus tracks. And we'll come down here to dynamics, and we'll go and add the limiter. And we'll expand this bus 1. In the bus 1 drop down, I'm going to come down to plugins, and notice now we get this limiter. This is different from this limiter, which is part of the dynamics controls. So any plugins that you've added to the track will appear under this section. Let's come across to limiter, and these are all the things that we can automate. Let's choose input gain. We can now add some automation for this however we want. In this case, let's add a keyframe using Alt and click. Notice down here that this input level goes green, and we'll add a couple more keyframes, and we'll just increase this keyframe. And as I scrub through here, watch what happens to this input level. And if I just play back now.
Hi, welcome back to Module 3. In this module, we'll dive into one of the most...
You can see that input level parameter being automated. Let's just close this. If you want to go back to clip level view, you can either select this drop down for a specific track and choose none. Notice now we're back in clip level view, or if you want to go back to clip level view for all of the tracks, even if we've got something selected here, you can simply come up and turn off toggle automation. So that's how we can manually create automation data. We can also record it in real time. Drawing automation is great, but you're not really responding to what you're hearing in real time. Recording automation parameter changes while the video is playing allows you to respond in real time, and it's kind of like capturing a performance of automation values. You move controls like faders and knobs in real time, and the changes get recorded as automation data. This means you can respond in real time while watching the picture and listening to the audio to create automation in a more intuitive way. Drawing automation or recording in real time both result ultimately in keyframes being added to parameters. Neither way is fundamentally better than the other, and they can both be used on the same track. Recording automation is even more tactile and intuitive feeling when you're using some of the Blackmagic Fairlight hardware control surfaces. So we're going to start off by once again toggling automation on by clicking this button, and then we're also going to click this button next to it to toggle on the automation controls. Watch what happens when I click this. We get all of these other controls show up. Okay, so there's a lot here to unpack. Let's start off with these automation modes. These control how automation data gets recorded in real time. Write mode records absolute changes to parameter controls positions, replacing any automation data that was previously there. You can use this to record the first attempt at automation or to completely re-record over any previously recorded automation data. If you set the automation mode to trim, this is going to record relative changes to parameters positions, and this will maintain relative existing values. You can use this when fine-tuning and refining the mix automation data. Next up, we've got these touch modes. These choose what happens when a control that can be automated is moved during automation recording. If this is set to off, that means no automation data is recorded unless you explicitly arm a track to record automation. In latch mode, automation is recorded once a control is moved and continues recording after the control is released until the recording playback is stopped. You can set the touch mode to snap. This means automation gets recorded when a control is moved, and then when the control is released, it ramps back to the pre-existing level. You can customize the ramping time in milliseconds by going up to DaVinci Resolve menu, Preferences, switching over to User, coming down to Fairlight, and modifying this glide time. The default is 250 milliseconds. So that was snap mode. What about snap latch? Snap latch is a mix of snap and latch modes. With this set, faders operate in snap mode and all other controls operate in latch mode. Next up, we have these on-stop settings. These determine what happens when stopping automation recording. If we set this to event, the last recorded automation value will overwrite any previous values all the way to the start of the next available automation value or keyframe in the track. Hold will delete any previously recorded mixing data from when the recording was stopped all the way to the end of that track. Setting this to return will mean the last automation value that was recorded is ramped back to the previously recorded automation values on that track. This enable section allows you to choose which controls you want to enable for recording automation data. You can toggle one or more of these on. If you turn on fader, this will automate track and bus volume changes. Mute will automate the mute button. Pan will automate all of the pan controls. EQ will automate all of the EQ controls. Comp will automate just the compressor controls in the dynamics window. Gate will automate just the gate controls in the dynamics window. Lim will automate just the limiter controls in the dynamics window. Sends will automate the send controls in the sends window. Plugins will automate all Fairlight, VST and audio unit AU plugins, and MISC will automate things like bus on off, insert and direct out controls. As you can see, there's a lot of different things we can change when recording track level automation. You can also record multiple automation tracks at the same time, which means you don't want to specify exact tracks to arm, but be careful with this as you might accidentally alter tracks by mistake, but it is quicker than manually arming tracks. So let's write automation data for track 1's fade volume, and we'll go and create a new track here. And for this audio 2 track, we'll go and automate the track panning. So let's go and set up our initial controls. We're going to select write mode because we're writing brand new automation or overwriting existing automation. We're going to change the touch mode to latch. This is so automation data will keep recording until we hit stop. For the on stop choice, we're going to choose hold. This is so that when we release a control, that value will be used all the way to the end of the track. And we're going to enable both fader and panning controls for automation recording. I'm going to hit Shift Z to zoom all the way out, and in pointer mode I'm going to hit home to make sure we're starting right at the start of the timeline. So we're going to make sure that this is toggled on, which it is because it's red, and I'm going to open up the pan controls for track 2 by double clicking on it, and we'll just move it out of the way up here. What I'm going to do now is hit play back and make some changes in real time. So we're going to be changing this left-right pan for track 2 and the fader for track 1. So let's go and hit space and we'll make some changes.
Hi, welcome back to Module 3. In this module, we'll dive into one of the most important aspects of audio editing, working with audio at the clip level. So in this module,
notice here that the controls turn red when we move them to show us we're recording automation data for them.
Making clips shorter by trimming the starts and ends, changing clip volume, and as part of this, we'll learn about the
What we can do now to prevent accidental recording is turn off fader and pan enables. What I'm going to do is switch the automation controls here to pan left right, and we've already got fader level selected for track 1, and we'll just zoom in. You can see we've got all of these keyframes which were recorded in real time as the track was playing back. Also notice that the last change we made was set for the rest of the track, even though we stopped recording before the end. This is because we chose hold mode. I'll just open up these pan controls again, and we'll play this back just so you can hear and see the fader control and the pan control.
Hi, welcome back to Module 3. In this module, we'll dive into one of the most important aspects of audio editing, working with audio at the clip level. So in this module, we're going to be learning about different aspects of audio clip editing, including moving clips.
So let's go and refine this automation a bit. I'm going to close these panning controls, and I'm going to change from write mode to trim mode. This is going to allow us to make relative changes to fine tune the existing automation, and we're just going to go and do it for the fader control for this first track. We'll also change the touch mode to snap. This is so when the fader is released, it will ramp back to the data we already recorded, or in other words, return to ramp back to any pre-existing automation data. I'm going to hit home to go to the start, and I'm going to hit play, and while it's playing back, I'm going to make fine-tuning movements to the fader.
Hi, welcome back to Module 3. In this module, we'll dive into one of the most important aspects of audio.
So you can see there, I changed the volume and it resumed all the way back up to the previous data. I'm going to do the same thing for this section here. Hit play.
Audio editing, working with audio at.
I moved the fader up here, and when I let go of the fader, it ramped back down to the pre-existing automation value. You can also select a part of the automation. Let's change to focus mode, and let's go and mark a section here. We've got loop mode turned on. I'm going to switch this back to write mode so we can try different automation settings. And I'm also going to change this to event so that the last recorded value overwrites any previous values to the start of the next available automation value or keyframe in the track. I'm going to hit play.
Different aspects of audio clip editing, including moving clips. Make out different aspects.
And this section will loop.
Clip editing, including moving clips. Make out different aspects of audio clip editing, including moving clips.
And if we don't like that,
of audio clip editing, including moving clips. Make out different aspects of audio clip editing, including moving clips.
this loop recording of automation of a specific section is a really great way to try out different possibilities. At the minute, if we changed any fader control on any track, it's going to record the automation data for that track. So it's quite easy to make mistakes, especially if you've got lots of tracks and lots of faders. You can specifically arm a track for automation when you're recording, when you want to be extra safe. So let's go and start off by choosing our recording setup. We'll choose write mode, we'll choose hold mode. We'll keep fader active, but we're going to set touch to off. And what that means is that we won't record any automation data automatically. Or in other words, it will disable all tracks for automation unless you opt in or arm recording. We'll switch back to pointer mode and hit home to go to the start. If I hit play now and start changing this fader, watch what happens.
Hi, welcome back to Module 3. In this module,
you can see we didn't record any automation data, even though we had fader enabled, and that's because we have touch mode to off. This means we have to opt in now to record automation data for a track. To arm a track for automation recording, you can either click this button here. When we do this, it turns red, and also the automation line turns red, or we can click the same symbol down here in the channel strip. Notice as well that the fader turns red to warn us that it's armed for recording. Now we can play back and go and make some changes to this fader, and automation will be recorded.
Hi, welcome back to Module 3. In this module, we'll dive into one of the most important aspects of audio editing, working with audio at the clip level. So in this module, we're going...
And you can see that time we did record automation data because the track was armed. Notice as well when we hit stop, the track was automatically disarmed. You can also arm multiple tracks for automation recording at the same time if you want to. There's a few ways to delete automation. We can select a range, come up to the Fairlight menu, come down to automation, and then choose erase. That deletes the automation for this selection. If you want to delete all of the automation for a track for all of the different properties, you can right click the track header and choose Clear Track Automation. We get this warning message box. We can click Reset to reset the parameters or Hold to hold the automation. I'm going to hit Reset because we want to clear it back to 0. And now you can see Pan and Fader Level have all had their automation data erased. You can also copy automation data. I'm going to select a range around these keyframes, come to the Fairlight automation menu, choose Copy. Going to click on this track to select it, go to the Fairlight menu, choose Automation, choose Paste, and now we've copied the automation data from track 1 to track 2. You can also do this with the focus tool. Let's go and copy this section of automation data. I'm going to hit Control C to copy, click here and hit Control V, and we've pasted the automation data to this section. The last thing I wanted to show you with track level automation is the concept of automation following edit. You can see we've got this button here, which is currently toggled on. We can turn this off, it goes grey, or turn it on to enable automation follows edit. Just going to close the mixer to give us more space and scroll across. So with this automation follows edit turned on, if I were to go and move this clip, watch what happens. It's moving the track level automation data that was on top of that clip to the new clip's position. Let's just go and undo that. But if I were to turn or toggle this automation follows edit off, then move the clip again, notice this time the automation data that was on top of that clip didn't move with it. It stayed where it was, just here. I'm going to undo that again, and I'm going to set this to none. I'm then going to hold down Alt and drag this clip to make a copy of it, and we'll turn this back to fader. And you can see that when we've made a copy of this clip, it hasn't copied the track level automation data. That's because this was turned off. We'll undo that, change this to none, toggle this on, and hold down Alt to copy this clip again, and once again turn on fader volume. And now we can see that the fader volume has been copied when we duplicated that clip. Just remember that once you've recorded automation data, you can go and modify it. So we could change it with the pencil tool here. We could level things out, make them go up and down. Just one quick gotcha as well. The pencil tool doesn't draw in reverse, only forwards. So that was a pretty big module, and I hope now you appreciate just how powerful automation is, especially track level automation. In practice, you can mix both types of automation, both track level and clip level. To recap this module, we learned about some of the differences between track versus clip level automation. And for clip level automation, we went and saw how we can automate the clip volume by manually adding keyframes. And this is different from recording keyframes. Next, we looked at track level automation. And once again, we saw how we can manually add keyframes, including using the pencil tool. But a really powerful way is to actually record automation in real time. And we saw loads of different options that we can use to control that. Fairlight has some really powerful tools to help us work more quickly and also customize our signal flows. In this module, we're going to be looking at buses, routing, groups, sidechains, and VCAs. So we're going to kick off this module by seeing how we can adjust the properties of multiple channels at the same time. The first method is more ad hoc, where we can quickly just group channels together and make changes. The second is a bit more formal, where we go and assign channels to something called a VCA control group. And the third is more comprehensive, where we can create our own custom groupings for tracks. All of these things help us to make changes to multiple tracks at the same time more quickly. We're then going to look at signal routing and buses. Buses allow us to set up custom signal chains, or in other words, the path through which audio takes, and they can be used for lots of different things, including creating sub-mixes for things like all of the dialogue tracks. We're going to learn how to add new buses and also route sound to this new bus, and we'll also learn about bus sends, which allow us to set up advanced signal routing. Related to buses is the idea of sidechains, and sidechains allow us to control things based on the audio from another track. Typically, when we use these, we're applying them to compression. Here we are back in Fairlight, and what I've done is I've set up a few different tracks. I've also color-coded them. These orange tracks are dialogue tracks where people are speaking. These teal tracks are sound effects tracks. We've got a couple of ambience tracks where we want to add background ambient sound. And we've also got this pink music track. We've also got the default bus 1 bus, and recall this is the main output bus where all of the audio gets routed by default and gets exported or rendered into the final output video. Also recall, if you don't see your buses, it's probably because you've got this toggle automation toggled off. And if we toggle this off, you can see the bus disappears. So if you're wondering where your buses are, just remember to toggle automation on. What I'm going to do is open up the mixer and recall that you can expand this out if you don't see all of your tracks. So let's start off with some of the different ways we can control multiple channels at the same time. Normally we want to do this when we want to make the same changes to multiple channels without having to go and do it manually to each thing, and this can save us loads of time. We'll start off by seeing how we can adjust multiple channel properties at the same time in more of an ad hoc manner. We don't have to set anything up in advance to be able to do this. So suppose we wanted to change all 3 sound effect tracks at the same time. With ad hoc grouping, all we need to do in the mixer here is select the first track and then use the control key and hold it down and click on the other tracks. Now we've got 3 channels selected in the mixer. If I try and change the sound effects 1 fader, you can see it's moving independently and it's not altering these other 2 channels. Just reset that. Once you've selected multiple tracks, you can hold down Alt and then make changes. And you can see now that it's altering the fader volume for all of the selected tracks in the mixer. And if I hold down the Alt button and double click, it's going to reset all of those faders. We can also do this with panning. Going to hold down the Alt key and we can pan left and right. You can also use this technique to apply the same effect to multiple channels. Once again, hold down the Alt key and then click the plus button next to effects and choose an effect. Let's go and choose noise reduction. And you can see now we've got the noise reduction effect added to 3 tracks. We can delete effects from multiple tracks by holding down the Alt key, clicking on this drop down and choosing delete plugin. And this will delete that plugin from all selected channels. You can also do this if you want to change bus outputs. If I hold down Alt and click remove bus outputs, they disappear. And once again, holding down Alt and clicking plus and bus 1 will add those bus outputs back in to all selected channels. So this is an ad hoc method. We didn't have to set anything up in advance. We can just click multiple channels and make the changes we want holding down the Alt key. Sometimes though, you might want to create a more organized grouping, especially if you're working with the same channels all the time. The first way to do this is to use something called VCAs. You can see in the channel strips, we've got this VCA section. And if you don't see this, you can come up to these 3 dots and make sure you've got VCA ticked. If I untick this, it disappears, and we'll go and tick it again so we can see the VCAs. Let's go and add the 3 sound effects tracks to the same VCA. To do that, I'm going to click in the VCA box and then choose one of these VCAs. Let's just choose VCA 1. If I drag this across now, we've got this additional VCA 1 channel strip. Let's go and assign the other 2 sound effects tracks to the VCA 1 group. I'm going to select them both, hold down Alt, click in the VCA section, choose VCA 1, and that will add both of those channels in to the VCA 1 group. Watch what happens now if I move this VCA fader. All of the 3 tracks that have been assigned to that VCA have their faders adjusted. We can still go and move these faders for these 3 sound effects tracks independently, but we can also move them at the same time using the VCA slider. Also notice down here we've got this VCA track and we can apply automation to VCA tracks. If I drop down the automation list, notice on a VCA we can only automate the fader level and the mute status. If I click the mute button, you can see the mute button turns on for all of the 3 tracks linked to this VCA, and the same for the solo button. It's important to understand that a VCA channel doesn't have any audio signal flowing through it. It's just an additional control that we can link to other channels. If we want signals to flow through something like this, we can use a bus instead, which we'll look at in just a moment. So I'm going to select these 3 tracks, hold down Alt, click on the VCA section and choose No VCA to remove them. And because we don't have any VCAs active, the VCA channel also disappears. We'll also go and reset these faders. These channels are selected. I'm going to hold down Alt and double click again to reset them to 0. The third way we can control multiple channels at the same time is by using track groups, and this is the most flexible option that we have. To access track groups, come up to the top and click this groups button. This will open up this groups dialog. We automatically get this all group, and if I click on this and then make changes down here, you can see it's altering every single track because this default all group includes any tracks that we have. Because this group's active, you can see down here that the group section has the word all the way across for every channel, and if you don't see this groups section, make sure that this track group option is ticked. I'm just going to click this button to turn off the all group. So continuing with the sound effects tracks, let's go and create a group that contains the 3 sound effects tracks. To create a group, come up to the top right here and click this button. This will open up the create group dialog. The first thing we need to do is select a name for the group. We can call this all sound effects. And now we want to choose what kind of things this group will enable us to control. Let's go and select everything. And we can also give this group a custom color. Let's go and give this a color of chocolate. The next thing we need to do is decide which tracks will belong to this new group. You can either add tracks individually by double-clicking in this left-hand section to add them, or you can click this button to add them, or this button to remove them, and you can select multiple tracks by holding down Control, clicking this button to add multiple tracks at the same time. Once you've configured your group, you can choose Save, and now we have this new group in the groups list. This group is also currently active. We know this because this G1 button is highlighted, and in the channels down here, the sound effects channels all have the currently active group, all SFX. Because this group is active, if I go and modify the faders, it's going to modify the fader for all of the tracks in that group. We can alter the panning, either using the shortcut in the channel strip or the main dialog box. Just reset that. And we can alter all of the things that we enabled here. If I go and click this button to disable this group, in the group boxes in the channel strips, that group name disappears, and now we're once again able to control things independently. There's also some keyboard shortcuts to make enabling and disabling groups even quicker. On Windows, you can hold down the Control key, this will be Command on Mac, and use the numeric keypad numbers 1 to 9 to activate or deactivate the first 9 groups you create. We've only got one group at the minute, group 1, so if I hold down Control and hit number 1 on the numeric keypad, you can see this group is now active, and if I hit Control numeric keypad 1 again, the group is now deactivated. If you want to quickly disable all groups, you can hold down the Control key, and I'm going to hit the star key on the numeric keypad while I do this. Watch what happens to this toggle. This disables all groups, and you can hit Control numeric keypad star to enable groups. You can of course just click this toggle as well. If I go and enable group 1 again, and then switch this toggle, it's going to disable any groups that were currently active. When we re-enable it, it remembers what was active, and of course we can go and turn groups on and off. You can also temporarily override the active group. So we'll go and turn on this all sound effects group, and once again the faders all move at the same time. To bypass this, you can hold down Control Shift on Windows. This will be Command Shift on Mac. And there, if I move one of these faders, even though that group is active, I can move these faders independently. But as soon as I let go of Control Shift, they'll all start moving together again. Just one thing that can be slightly confusing is this selected checkbox. This selected checkbox doesn't make the group active or deactive. It just makes it easier if you want to create groups from other groups. If you want to edit a group, you can click this symbol next to the group and then go and change the name and the color and what it controls. Notice here that this group controls editing. So if we go to one of these sound effects tracks, I'll just zoom in a little bit, we'll drag this across here and we'll go and make an edit to this clip. Notice I've got this clip selected and I'm going to trim the end. Notice how it's affecting this other clip, and that's because we had the editing checkbox enabled in this group. If I disable this and hit save, notice now it's not affecting the other sound effects. So you can go and create multiple groups. Let's go and create one for dialogue. And for this, maybe we don't want to enable editing. We just want to enable the fader just so we can control the volume of all dialogue tracks at the same time. Let's go and select 2 dialogue tracks and add them. And let's choose a custom color. Let's choose violet and save. You can see the 2 dialogue tracks down here are now added to the active dialogue group, and the sound effects tracks are also added to a different group. That means if I move these sliders, it's not going to affect channels that have this group assigned, and if I move channels with this group assigned, it's not going to affect the other group. You can also quickly add or remove channels to an existing group by clicking the group dialog, and this doesn't make sense for this example, but we could quickly modify the all sound effects group to include dialog 1 and 2, and if I come up here and open up the all sound effects group, now we've got the 3 sound effects tracks added to that, but that's not what we really want for this. So I'm just going to remove them and click save. And for the all sound effects tracks, we'll modify that. We'll remove these dialog tracks and we'll add in sound effects 1, 2 and 3 and save that. As we saw before, you can enable or disable these groups, and when the group is disabled, the faders will move independently. To delete a group, you can come over to the trash bin icon next to the group, click delete and then confirm to delete groups. And we'll just go and close the groups section. So all of those things are really about improving the speed of our workflow when we're working in Fairlight. They're not really about the signal flow. To customize the signal flow or the signal routing, we can use buses. A bus is a place where lots of audio data can be combined and then acted on in a common way. By default, we get this bus 1, which represents the final output to the speakers and the rendered exported video file. You can see by default, all of the tracks are routed to this bus 1. If I go and play back a section of this, and we haven't done any mixing yet, so this is going to sound pretty loud. You can hear that we had some output. But if we were to remove this bus output for each of these channels, which I can quickly do by creating an ad hoc group, holding down Alt and choosing Remove Bus Output. If I play back now, we won't hear any sound, and that's because even though these channels have audio clips on, they're not actually being routed to any output. Let's just hold down Alt, click plus, and choose bus 1, so we actually get output once again. So you can use buses to create submixes. For example, all dialogue audio tracks could go to a dialogue bus, so we can quickly make changes to the sound of all dialogue tracks. You could also have a submix bus for each language of the dialogue. If you have it dubbed into different languages, you could have a submix bus for all the sound effects, and you can also use buses to add the same audio effect to multiple channels. So let's go and add a new bus for the dialogue. To do that, come up to the Fairlight menu and choose bus format. This will open up this bus format dialog box. You can see we've got the default bus 1 showing up here, but let's go and add a new bus by clicking this add bus button. We can click here to give this bus a name, so I'm just going to double click and let's create a dialog bus. We can choose what format we want this bus to take, mono, stereo, or one of these multi-channel formats. Because dialogue is usually mono, we're going to select mono for this bus. And if we want to, we can give it a custom color. Let's choose orange because we've got orange dialogue track colors set. And now we can simply hit OK. And if I expand this across, we've now got this bus 2 called dialogue. What we can do now is change the bus outputs for these dialogue tracks, and instead of sending them to the main bus 1, we're going to send them to this dialogue bus. So I'm just going to click dialogue there, and we'll do the same for this dialogue 2 track. Helpfully, the button also changes to the color of the bus, which we set to orange. I'm just going to mute these other tracks just for a second and play back this section, which contains these dialogue tracks. But have a listen to this. You can hear or not hear that we don't have any output for these 2 dialogue tracks. Let me just go and do that again and watch what's happening down here. We're actually getting audio data sent to this dialogue bus because we can see it in the meter here, but it's not being output to the speakers. That's because we need to tell this dialogue bus where to output its signal to. We can do that by clicking on bus outputs and choosing bus 1. Now any audio signal that comes into this bus 1 will run through all of these effects and then be output to bus 1, which is the main output bus. And that means now if I play this back, and these changes get recorded as automation, we can now hear the dialogue. Now we've got this dialogue submix bus, we can alter the volume of all dialogue tracks by just changing the fader on the dialogue bus. Let me show you an example of that. We'll do this by manually adding, and then we'll look at track level automation. When it comes to track level automation, so this looks a bit similar to the VCAs or the track groups, but remember a bus is different from a group or VCA because it's got audio data passing through it. That means we can modify the audio that's being passed into this bus. I'll show an example of that. We'll do this by manually adding keyframes, and then we'll look at track level automation. When it comes to track level automation, we can manually add keyframes. So you heard there that we can alter the panning for every dialogue track that's routed into this dialogue bus. This also applies to the dynamics, the EQ, and also effects that we can add to this bus. Let's go and see an example of using an effect on a bus. I'm going to come up to the Fairlight menu. We're going to choose bus format. I'm going to click add bus. We'll click here to give this new bus a name. We'll call this SFX. We'll change this to mono because all of the sound effects tracks are also mono, but we could leave it as stereo if we wanted to. Let's give this a color of yellow and click OK. Now we can select the 3 sound effects tracks and reroute them to our new SFX bus, remembering to hold down the Alt key. And if we expand this across, we've got our new yellow sound effects bus. Just going to unmute these by holding down the left mouse button and dragging down, and we're going to solo these tracks by clicking on the solo button and dragging down, just so we can work with the sound effects on their own. And if I play this back, once again we don't get any sound, and that's because we haven't output the sound effects bus to bus 1, and now we should hear things, which we do. Because now all of the sound effects tracks are routed to the sound effects bus, we can add effects that we want to be common on all sound effects that get played. Let's go and choose an effect to do this, and maybe we choose the distortion effect, and we can choose one of these distortion types. Let's go and choose lo-fi radio. That sounds pretty terrible, but you get the idea. Just going to close that. You can also have multiple bus outputs for a given track. To do that, just click the plus button in the bus output section and add a new one. So let's also route this dialogue track to the SFX track. And now when we play back this first dialogue track, and then we'll look at track level, it's going to be routed to both the dialogue submix and the sound effects submix, which has the distortion effect applied. And to remove it, we can click on this drop down and choose remove bus output. Just going to mute these things. We can also quickly now mute all of the dialogue, just like with clip level automation, and by clicking the mute button on the submix over time. When it comes to track, we can also record to control the output level that gets sent down the bus output, in this case to this dialogue bus. You just use the channel faders. Let's go and play this back for this second track. Automation. And as you can see, as I reduce that fader, it's no longer sending the signal to the dialogue bus. This is where we're drawing or creating the and we can even create automation for buses, and we get a lot more choices here than we did with the VCA. You can even route the output of one bus to another bus to create really complicated or flexible layouts or signal flows. Alright, let's talk next about bus sends. You can access the bus sends by clicking this plus button here and choosing where you want to send signal to. If you don't see bus sends, come up to these 3 dots and make sure this item is ticked. Bus sends allow us to send the output to another bus and at the same time send a copy of the signal to a different bus. One use for this is to create an effects bus which you can send multiple signals from multiple tracks, but alter the volume that's being sent to that effect bus. This will make more sense in just a minute. What I'm going to do to simplify things, I'm going to select these dialogue tracks, hold down Alt, and just reroute them to the main bus 1 output. And if we wanted to, we could go and delete this dialogue bus by coming up to the Fairlight menu, choosing bus format, selecting the dialogue bus, and choosing the remove button. We get a warning here, but we'll just go and remove it anyway and click OK. Now we're back to the starting state where the 2 dialogue tracks are being output to the main bus 1 output. Say we wanted to add some reverb or some echo or another effect to all dialogue, but we wanted to be able to control the amount from each of the source tracks. Let's come up to the Fairlight menu and we'll choose bus format and we'll add a new bus, and for the bus name, we'll call this verb, which is short for reverb. We're going to leave this stereo and let's give this a color, let's say lime, and click OK. And here's our new reverb bus. We need to make sure that we're sending the output from this bus somewhere. So we'll send it to the main bus 1 output, so we actually get something back. But if I play this back at the minute, notice what happens in this reverb meter. We don't get any signal.
Look at track level automation. When it comes to
you can see we didn't get any signal in that bus because we're not sending any signal to the verb bus. We want to keep dialog 1 and dialog 2 sending it their signals to the main bus 1 output, but we want to additionally send some signal to the reverb effects bus. To do that, we can use the bus sends section. So let's just work with track 1 to start with. I'm going to click plus next to bus sends, and then I'm going to choose where I want to send additional signal to. In this case, it's the reverb bus, and it shows up here. If I play this back, notice what happens in the reverb bus. We're not going to get anything yet.
And then we'll look at track level automation.
Because we need to configure this bus send. To configure it, you can click on the middle here, and it's going to open up the properties for this bus send. At the minute, you can see the send level is -infinity, which means we're not sending any signal. If I double click on this slider, it's going to reset it to 0. If I play this back now, we should see some signal down here.
And then we'll look at track level automation.
Which we do. At the minute, the track fader level here is also going to affect the signal sent from this bus send to the reverb bus. And I can show you that. I'm going to play this back. I'm going to alter this fader and watch what happens to the signal level over here.
And then we'll look at track level.
You can see we've got no signal going to the reverb bus.
We can manually add keyframes.
And now we've got signal again. And that's because by default, it's going to send the signal after the fader has taken effect. If you want to send the signal or the volume level before this change is made in this main fader, you can click the pre button. This means pre-fader. I'm going to play this back again and alter this main fader, but this time you won't see any change in the verb bus.
And then we'll look at track level automation. When it comes to track level automation, we can manually add keyframes just like.
You can also use this panning control to send things to the left or right of the destination bus send bus. With this pre-selected, even if we mute the main track, we're still going to get audio data sent to the bus. By enabling this pre-fader option, we can fine-tune how much signal we send to the reverb bus. At the minute we don't actually have an effect on here, so let's go and add a reverb effect. Let's go and choose something quite big. We're going to make sure this dry wet setting is all the way 100% wet because we're not going to mix in any of the original signal. This is an effects bus, so all we want coming out of this effects bus is the effect. So we don't want to mix in any of the original signal in this case. Now if I play this back, we should hear some reverb. And that's a lot of reverb. I'm just going to close that effect for the minute. I'm going to unmute the main dialog channel, and I'm going to play this back, and now we can use this control here to add more or less reverb effect for dialog 1.
And then we'll look at track level automation. When it comes to track level automation, we can add keyframes just like with clip level automation, and then we'll look at track level automation. When it comes to track level automation, we can manually add keyframes just like. So now we've got that set up, we can really quickly go and add a reverb effect to any other track by simply choosing bus send, sending some data to the verb bus, configuring things how we want. Let's say we want a lot more reverb for dialog track 2. And now when I play this back, you'll hear a difference between this dialog 1 and dialog 2. Just like with clip level automation, and we can also use the pencil tool. We can also alter the overall loudness of the reverb effect for all tracks that are being sent to it by using the bus fader here. I'll show you that in action. We'll do this by manually adding keyframe. Is falling into two basic camps. Manually created automation. This is where we're drawing. This also means if you want to fine-tune the reverb effect, maybe making it a bit less cathedral-like, you can simply change it and it will make the change to all tracks that have a bus send to this reverb bus. The final thing we're going to look at now is sidechains, and we can use sidechains to make one
control or effect respond to a different track. Typically, we use this with compression. So what we're going to do here is I'm just going to mute the reverb because that can get quite annoying how we've got it set up at the minute. Or I could have come over here and just disabled these bus sends, and now we won't get any signal sent from these bus sends. So what we're going to do is we're going to make use of a sidechain to automatically reduce the volume of this music track when the person talking on dialogue track 1 has some signal. So in other words, we're going to control the compressor on this music track from the audio signal coming from the dialogue track. To do that, what we need to do is come down to the source. Remember, this is the dynamics compressor for the music track, not the dialogue track, and select where we want the signal to come from that's going to make the compressor kick in. In this case, it's dialogue 1. I'm going to enable the compressor, and now we can start to manipulate these compressor settings as we learned about in the previous module. Just going to play this back. We'll do this by manually adding keyframes. And you can see now we've got this sidechain meter activated. The signal that displays in this sidechain meter is the signal that's coming from whatever was selected down here, in this case dialogue 1. Now to actually enable the sidechain, even though we're getting signal here, to make the compressor respond to it, we need to click the on button. Now if I play this back, and then we'll look at track level automation. You can hear we got that kind of pumping effect. What we actually want is for the music track to stay quiet while people are talking and then come back. We don't want it coming back every time there's a slight pause in the dialogue. As we learned in the previous module, we can make use of the attack, hold and release settings to do this. Now, depending on what the talking is and how many gaps there are in the dialogue, you're going to want to choose different settings here, but you're typically going to want to have a bit of a hold and a release. And we're typically going to want the compression to kick in fairly quickly after people start talking. So let's listen to this. By manually adding keyframes, and then we'll look at... You can hear that as soon as people start talking on dialogue 1, the background music goes quieter. But you can still hear some pumping here. We'll do this by manually adding keyframes. And we can experiment with the hold and release times. We'll do this by manually adding keyframes, and then we'll... to get the effect that we want. We'll do this by manually adding keyframes, and then we'll look at track. And you can hear now that we don't have that pumping effect. The music stays pretty much the same level of volume reduction, even when there's slight pauses in the dialogue. So that brings us to the end of this module. In this module, we started off by learning how we can adjust the properties of multiple channels at the same time to save us time when we're making changes. We learned that we can do this with ad hoc grouping, where we select multiple channels and then modify things. But if we want a bit more formality, we could instead use VCA controls. But for the ultimate flexibility, we can create custom track groups and enable or disable different things that the track groups can control, such as the fader volume level. We learn that these three things don't affect the signal flow. For example, they don't allow us to affect the signal for multiple tracks with something like an effect, but to get more control, we can make use of custom buses and signal routing. We saw an example where we created a submix bus for the dialogue. We learned how to create a new bus and then send bus output from one channel to the new bus. We also learned about bus sends for advanced routing, such as creating a reverb effect bus. Finally, we looked at sidechains, which allow us to route signal data from one track to control the compressor on a music track from the audio data coming from a different track. In the demo, the dialogue track. We've learned about so many powerful features so far in this course. Let's start applying what we've learned to mixing a project. When we talk about mixing, just like cooking, we're mixing a lot of ingredients together so the final result tastes good. For example, we could have dialogue, this is people speaking, music, sound effects, Foley sounds, and background ambience. We've got many powerful ways to mix all these things together in Fairlight so that everything is well balanced and nothing stands out as being too loud or too quiet. So we're going to kick off this module by editing the dialogue tracks. The dialogue is usually the most important thing to be able to be heard clearly in the overall mix. So we're going to perform some initial dialogue edits, such as splitting out different people talking to different tracks. We'll perform some initial balancing of the levels of those dialogue clips, and we'll see how we can use clip level automation to perform surgical cleanup, such as if we have the sound sounds of lips smacking. We'll also go and apply micro fade ins and fade outs to make sure we don't have any annoying clicks or pops. We'll also look at adding some noise reduction for vocals. Once we're happy with the dialogue tracks, we'll go and mix them in with the other audio elements. When we're mixing elements together, we've got 4 basic building blocks or tools that we can use. We can adjust the volume, the panning, the equalization, and the dynamics. We can also make use of automation to further fine-tune how everything is sitting in the mix. So here we are back in Fairlight, and we're going to be mixing together this short segment of a film where we've got characters about to enter a ship that's sent out a distress signal, and they're trying to find out what's happening. At the minute, we've got 1 dialogue track. This is this orange track, and this contains the dialogue for 2 of the characters in the scene. We're going to be splitting those out in just a second. We've got 3 sound effects tracks. We've got 2 ambience tracks, and we've got this music track. The first thing we're going to do is the dialogue editing, and the overall goal here is to improve the clarity of the spoken word and reduce unwanted background noise as well, and also get rid of unwanted speaking noises like unwanted lip smacks or tongue clicks. So what I'm going to do is I'm going to right click here, and we're going to add a new mono track. I'm going to make this track color orange to match the other dialogue track above it. And I'm going to click the solo button, hold down the mouse button and drag down, just so we're soloing these 2 tracks and we're not going to hear the background music or anything else. I'm just going to play this back for you, and the volume's quite low at the minute, but we're going to fix that in just a second.
Captain, we have positive lock. Pressures equalized. Ready to open the hatch on your command. Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! No sign of movement, Captain. Looks like backup power's working at least. No sign of a firefight, no blood. So where is everyone?
So we've got 2 different characters talking in that 1 dialogue clip. We've got the captain and also the officer. The reason we want to split out the different people onto different audio tracks is so we can apply things like EQ to each person individually. The EQ settings for one person's voice won't necessarily sound good on the other person's voice. So by splitting them out onto separate dialogue tracks, we can really give each person's voice its own special treatment. I'm going to rename this first dialogue track by clicking up here. We'll call this Captain, and this new audio track that we just added we'll call Officer. We now need to play through this clip and move any of the officers talking to this second dialogue track. We can make use of some quick shortcuts. We can use the up arrow and the down arrow to move backwards and forwards between clips. We can use Control, Alt and the up and down arrows to select a track above or below. So if I hold down Control and Alt and hit the down arrow, we can move down the tracks, and Control, Alt and up arrow moves up the tracks. And we can use the familiar Control X to cut and Control V to paste. We'll start off with this first part.
Captain, we have positive lock. Pressures equalized. Ready to open the hatch on your command.
I'm going to hit Control B to split the clip. Use the up arrow to go to the start and select this clip. Hit Control X to cut. Hit Control, Alt and down to select the track below it, and then hit Control Paste. You can see that's a really quick workflow for moving parts of clips around. We'll hit the down arrow to go to the next clip and use Control, Alt and up to move to the captain's track and play this section back.
Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go!
We'll hit Control B to cut that. We're going to leave that section on the captain track because that's the captain talking.
No sign of movement, Captain.
That's the officer again, so we'll hit Control B to cut, hit the up arrow, hit Control X, hit Control, Alt and down arrow, and hit Control V.
No sign of movement, Captain. Looks like backup.
Control, Alt and up, Control B, that's the captain again.
No sign of a firefight, no blood.
Control B, up arrow, Control X, Control, Alt down, Control V.
No sign of a firefight, no blood. So where is everyone?
Now we have the separate people talking on separate tracks. The next thing we can do is we can clean up the starts and the ends of these individual clips. And to do this, we can expand the clips down so we can really quickly see the waveforms. So this clip here, if we just play this back, there's a lot of empty space. And then we have a breath sound. That all happens before the actual dialogue words are spoken.
No sign of movement, Captain.
When it comes to breath sounds, normally you're going to want to keep them in for dramatic work, narrative films, documentaries, because it adds that sense of humanness and realism. If you're editing adverts or commercials, quite often you're going to want to cut out the breath sounds to a larger extent because the people paying for the commercial don't want anything to distract from the product they're trying to sell. So in this case, we could leave this breath sound in, but it's actually quite distracting. So in this example, I'm going to trim this off. We're in pointer mode here, and we'll just go and trim the start of that clip.
No sign of movement, Captain. Safety's off.
We've got a bit of extra space at the start of the captain talking here, so we can trim this out, and this is also going to help get rid of any noise at the start. And I'm just going to try and pull it this way, and when I let go of the left mouse button, you can see it kind of snaps back. If you're having problems with adjusting things precisely, you may want to turn off this magnet tool here. This is going to enable and disable snapping. You can also use the N key to toggle that off. Now I can trim this in fine increments without it snapping back. We can do the same thing for this part of the captain talking, and we can trim the end off here.
So where is everyone?
So all we're doing here is we're just tidying things up.
No sign of a firefight, no blood.
You can also use this trimming technique if you have lip smacks or mouth clicks before or after the actual speaking part of the clip. If you listen to this part of the audio, you can hear that in the middle of this clip, we've got the captain's character has this nasty mouth noise, like a lip smack or tongue click. We'll handle that in just a second. So now we've got the dialogue on separate tracks and we've done basic trimming of the starts and ends. We can start to balance the levels of these dialogue clips. So I'm going to turn off solo for the officer. I'm going to open up the mixer. And we're going to be working with this track here. So we're still working at the clip level and we want to balance all of the clips for the captain so the volume levels are correct. We want all of these clips when they play back to show as mainly yellow in the track meter for the captain's track. Maybe you'll have a tiny bit of red for a loud scream, maybe it'll be in the green for a quiet whisper, but for the most part we want dialogue in the yellow. On the meter, the dynamic range for dialogue should be about -20 decibels for the most quiet whispering part, about -15 decibels for a person with a softer voice, about -12 for a person with an average voice, about -10 for a person with a louder voice, and maybe all the way up to -3 dB for screaming at its loudest. Basically, the average level should be around the -12 dB mark. So let's go and play back this first clip and watch what happens down in the captain's meter.
Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go!
You can see for the first part of this clip,
Off, everyone. When we enter the ship, set up standard.
we're getting around -20. So this is too quiet because we want this to be around the -12 mark on average. If you want a bigger meter, then you can add the meter plugin and play it back. To do that, click the plus button on effects, come down to metering and choose meter. You can expand this out to make it even bigger. And if I play this back now,
Safety's off, everyone. When we enter the ship, set up standard.
it's just a bit easier to see than the smaller version in the channel strip. Let's start off by setting the volume level for this first part. We're going to have to deal with this part where the captain raises his voice, but let's start off with the normal talking. So I'm going to play this back, and while it's playing back, I'm going to alter the volume line here so we get about a -12 on this big meter.
Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1.
So that's not too bad.
Safety's off, everyone. When we enter the ship.
Maybe a tiny bit loud. We'll just reduce this.
Safety's off, everyone. When we enter the ship, set up standard defensive posture.
And remember that you can hold down the left mouse button on this volume line and hold down the shift key to make it easier to increment or decrement the value. Let's try that.
Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1.
I might just increase that just a tiny bit.
Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1.
You can see now most of the dialogue when it's being spoken is in the yellow zone, and we're around that -12 mark. Because the captain has what we could consider a louder or more prominent voice, we might want to try and get this to about the -10 mark.
Safety's off, everyone. When we enter the ship, set up standard
So we can go and increase this a little more, let's say by another 0.5 decibels.
Safety's off, everyone. When we enter the ship, set up standard defensive posture.
Okay, so that's the first part of the talking. What about this bit at the end where the captain shouts, go, go, go? We obviously are going to need to reduce the volume on that, so we can maybe switch over to the focus mode, and we'll drag a selection here over that part of the talking, and we'll lower this section down. So if I play this back and watch the meter,
Go, go, go! Go, go!
we're still up around here, which is about -6. So remember, when we're editing the volume of dialogue, we don't want to take away from the drama or the emotion. So we don't want to squash this go, go, go right down so it's exactly the same level as the normal speaking. We need some kind of ups and downs in the volume to help portray the emotion or what's happening in the dialogue. So we could keep moving this line and then playing it back and then moving the line and playing it back, but we might give it a little bit more so we get that emotion.
Go, go, go! Go, go, go!
Remember, you can always come back here and play the whole thing just so you can hear it in relation to the other captain's dialogue.
Enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go!
So we could probably increase that even a little bit more, but we'll leave it there for now. Rather than just altering these things and then playing it back and then altering it again and then playing it back, there's a quicker way. What we're going to do is we're going to select this entire clip. This is going to give us this range. We've got loop playback turned on at the top here, and while this is playing back, we can use Control Alt and the negative key on the keyboard to lower the volume, or Control Alt and plus to increase the volume. So let's go and play this back.
Looks like backup power's working.
And then we can use Control Alt plus.
Power's working at least. Looks like backup 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 power's working.
And you can see that's a really quick way of altering the volume. So in this part of the dialogue, the captain's actually whispering or using a softer voice. So we don't want this to be at the same level as the captain talking earlier. So in this case, we're going to aim anywhere between -20 to -15. I'm just going to keep playing back.
Working at least. Looks like backup power's 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 working at least.
Something like that should do it. So we need to go and follow the same process for the rest of these clips. This part of the captain talking, he's not whispering anymore, so we can set that to roughly -12.
Is everyone? So where is everyone? So where is everyone? So where is everyone?
And remember, the captain has a slightly louder, more powerful voice. Okay, let's move on to the officer, and we'll follow the same approach. This first part is the officer talking in a normal volume, but the officer kind of has a slightly softer voice than the captain. So instead of -12, we're going to aim for about -15. I'm going to move the meter from the captain and drag it over to the officer, and we'll play it back and use Control Alt plus and minus to alter the volume.
Captain, we have positive lock. Pressures equalized. Ready to open the hatch on your command. Captain, we have positive lock. Pressures equalized. Ready to open the hatch on your command. Captain, we have positive lock. Pressures equalized. Ready to open the hatch on...
And then we'll do the same for the next clip. This part of the clip, this character is actually whispering. So again, we're probably going to aim for about -15 to -20.
No sign of movement, Captain. 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 No sign of movement, Captain.
Something around there. And this final officer clip. They're talking normally again, but again, their voice is softer. So we'll aim for about -15.
No sign of a firefight, no blood. 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 No...
And let's close this meter and we'll remove it from this track. We'll make sure both tracks are soloed and let's listen back to what we've got now.
Captain, we have positive lock. Pressures equalized. Ready to open the hatch on your command. Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! No sign of movement, Captain. Looks like backup power's working at least. No sign of a firefight, no blood. So where is everyone?
So we did a pretty good job on the first pass there, but we could go and tweak things a bit more. I think this section here, this officer needs to be a tiny bit louder.
No sign of a firefight, no blood.
So we'll just modify the volume, hold down the shift key, and we'll increase it by 0.5.
Looks like backup power's working at least. No sign of a firefight, no blood. So where is everyone?
And you could obviously spend a lot more time on this than I'm doing here. And just as a quick bonus tip, if you don't have the time to do all of this on a clip-by-clip level, you can try and make use of the AI-powered dialogue leveler track effects. So let's go and turn this on for the captain. You can enable it by clicking this button here for the dialogue leveler and opening up the controls by clicking here. There's a few different options. For example, you can use allow wider dynamics. This is going to let you go from whispering to shouting without crushing the dynamic range quite as much. Or you can optimize for moderate levels, or if you've got a lot of low vocals, you might want to lift, or just leave it as the defaults for now and take a listen just to the captain.
Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go!
So if you don't have time to do all this manual editing of clips, you might want to give the dialogue leveler a try. I'm going to turn it off because we're not using it here. All right, let's come back to the captain's clip and have a listen around this point. We get a nasty lip smack sound.
Defensive posture.
Just going to use Control Plus to zoom right in, and it's this part here. So we can use clip level automation to clean up things like this. We can also use this to clean up things like plosives. That's where the microphone picks up p, or b kind of sounds. And if you do have plosives, you can try and bring them down by about a third of the initial volume, but you still want to try and keep things sounding natural. So let's go and fix up this lip smack. We're in focus mode still, and I'm just going to drag a section over here, and we really don't want any lip smacking sounds, so we can reduce that all the way down. Let's have a listen now. And that lip smack has disappeared. Okay, if we wanted to, we could also apply micro fade-ins and fade-outs to the start and end of every dialogue clip. We'll do it for the captain track here. We'll come up to the Fairlight window. We'll choose batch fade settings. We'll make sure crossfade is turned off for the minute, but we could add that if we have adjacent clips. We're going to leave the fade type to this linear type. And we'll start off with the unit set to frames and the length set to 30 frames for fade in and fade out. This is going to be too long, but if I click apply, you can see it's applied the fade in and fade out for the selected clip, but this is going to be too long.
Safety's off, everyone.
You can hear it affects the start of the captain talking. So we just want to apply micro fades just so we can clean up the start and ends automatically of these clips. I'm going to hit Control Z to undo that. We'll go and select all of the clips for both the captain and first officer, come to the Fairlight menu, choose batch fade settings, and we're going to change this from frames to milliseconds. And now the length is only going to be 30 milliseconds. And if we hit apply, you don't see anything at the start, but if we zoom right in here, you can see now we've got this micro fade added to the start and end of every dialogue clip that we selected. So Resolve has a number of different ways that we can try and reduce noise. So for example, we can open up the effects section here. We can come down to restoration. We could choose de-hummer or noise reduction, and we saw noise reduction earlier in the course. But as of DaVinci Resolve 18.1 in the studio version, there's the voice isolator. You can turn on the voice isolator by clicking this button here and opening up the controls by clicking here. The voice isolator uses an AI to try and remove background noise from dialogue, and it usually does a really good job. We only get one control, and that's the amount here. Generally speaking, you want to try and set an amount that's low enough to reduce the noise, but not too high that it's going to make the dialogue sound weird. I'll just play back this because we've enabled it for the captain.
Safety's off, everyone. When we enter the ship, set up standard defensive posture. Safety's off, everyone. When we enter the ship, set up standard defensive posture.
So for demonstration purposes, let's go and add a little bit of voice isolation here.
Safety's off, everyone. When we enter the ship.
And we could do the same thing for the officer. Click here, open up the controls, and then dial in the amount of voice isolation we want. Okay, let's just shrink things down a bit. And now we can follow the same process for clips on any sound effects tracks with the aim of getting all the effects to a similar volume level. Of course, just like with dialogue, some effects by their nature are louder than others, so we need to respect that. For example, we don't want to make a mouse's footsteps the same volume as an explosion. You might also have sound effects for different things on completely separate tracks, especially if they're long-running sound effects, like the background hum and beeps of a starship's computer or medical equipment in a hospital room. Down here we've got two ambient sound effects. They're more long-running effects, and they're both happening at the same time. If you do have lots of different sound effects on the same track and they have wildly different volume levels, you can make use of automation, and we learned about that earlier in the course, to control the volume of that sound effects track over time. However, in the interests of being as efficient as possible, you may want to have different sound effects tracks with different loudness levels, just so you don't have to worry about automation. Also remember that we can use things like VCAs and track groups to help control things, and also use submix bus to control the dynamics or EQ of multiple tracks joined together if we want. Once we've got things mixed together, even when there's no dialogue, we still might have music or sound effects coming up to that -15 to -10 level, depending on the context of what's happening in the picture. Always remember to use the meters as your friend. Once we've got the levels of these other clips leveled out, we can move on to the mixing stage. Let's turn off these solos and we'll solo these sound effects. Let's have a listen. And I'm looking at the meters down here. And I'm also looking at the bus 1 meter for the overall level. So all of those tracks playing together are hitting about the -15 mark. So I think we'll leave those there for the moment, but we could of course alter the volume for individual elements here if we wanted to. We'll move on to these two ambience clips now. And you can hear they're way too loud. So let's start off by soloing this first one. And if we want to, we can zoom in to make things easier. And we'll drop this down. That's giving us about -15. About -20. We'll add the second ambience track in. Probably going to have to lower this to start with. And the two of those playing together are hitting between -15 and -10. So we might want to tweak this just a bit more. And now they're hitting about -15 on the bus 1 meter. The final track we're going to look at is this music track. And this music is supposed to be some background music right up until this point where the door opens and we can imagine them running into the new ship, trying to find out what's happened. But this music is going to be playing while the dialogue's happening as well. So we're going to want to set this volume quite low to start with. Make sure we solo the captain as well, and also the first officer.
Captain, we have positive lock. Pressure's equalized. Ready to open the hatch on your command. Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go!
So that's not sounding too bad where it is. Now that we've balanced the levels of the dialogue and the sound effects, and we've set our background music to its starting level, we can start the actual mixing process. So the mixing process tries to get everything sitting nicely. We can alter the volume levels, the panning, the dynamic range, and the equalization. Let's start off with volume. Normally, we're going to start with all of the faders set at the default 0 dB, which you can see here. If they're not, just double click them to return them to 0. We're going to make sure all of the tracks are not muted and nothing's soloed, so we get to hear everything playing at once. And we're going to hit home to go to the start. We're going to play this back, and we're going to listen to anything that sticks out as being too loud, especially if it distracts us from any dialogue.
Captain, we have positive lock. Pressure's equalized. Ready to open the hatch on your command. Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! No sign of movement, Captain. Looks like backup power's working at least. No sign of a firefight, no blood. So where is everyone?
So there were a couple of problems with that. The sound effects in my ears are way too loud.
2, 1, go, go, go.
And these ambient tracks down here are too loud. So assuming we've set the dialogue clip levels correctly in the previous step, we don't want to actually increase the levels of the dialogue tracks. Instead, we want to reduce the volumes of the other things that are distracting from the dialogue. So we can do this by lowering the fader track volumes until the elements are no longer distracting from the talking, but they can still be heard. So we're going to do this with these two tracks, and I'm going to create an ad hoc group by selecting the first one and clicking the second one, so we can work with both of these ambience tracks together. And I'm just going to hit play, hold down Alt.
No sign of a firefight, no blood.
And reduce those. And of course, we can use the focus mode tool, drag a selection, turn on loop mode. So we're just going to loop through this.
No sign of a firefight, no blood. So where is everyone? No sign of movement, Captain. Looks like backup power's working at least.
Something like that sounds about right to start with.
1, go, go. 1, go.
Just going to fix up these sound effects by clicking Alt, dragging down.
1, go, go, go.
So those three sound effects aren't quite as distracting now, but remember, we can always come back and adjust them later on if we need to. So we can continue to fine tune the faders for all of the different tracks. What we want to do is keep our eyes on the meter, especially the bus 1 meter, where we're aiming for around that -15 to -10 total volume, even when multiple tracks are playing at the same time. Obviously, we are going to get some dynamics, especially if we've got explosions or people screaming.
Captain, we have positive lock. Pressure's equalized. Ready to open the hatch on your command. Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! No sign of movement, Captain. Looks like backup power's working at least. No sign of a firefight, no blood. So where is everyone?
So I still feel like these two ambience tracks are a little bit too loud, so I'm going to select them both, hold down Alt, reduce them a bit more. And I'm also going to zoom in, and I'm going to add some fades because they do sound a bit abrupt when they come in. Have a listen to that.
No sign of movement, Captain. Looks like backup power's working.
And that sounds a lot better. Again, you can spend more time here and really finesse things, but the next thing we can do is actually look at panning, and this is the ability to place a sound somewhere in the listener's hearing space. So in movie theatres, this is usually a surround sound hearing space where sounds can be placed behind the listener, in front, to the left or right, and even overhead. A more basic but still powerful listening space is the stereo field, where the listener has a speaker or headphone for the left ear and for the right ear. We can place a sound to the far left, the centre, the far right, or anywhere between the left and right. In this course, we're assuming a stereo deliverable, so we won't be talking about surround sound. To pan a track, you can use the blue dot in the channel strip, or we can double click it to open up the pan controls. I'm just going to double click here to reset. So this square area represents the panning from left to right, and if we're working with surround sound, we can also pan towards the front and the back. So what we're going to do is we're just going to zoom in on these ambience tracks, and we'll go and solo these, and we're going to go and switch on loop playback. We'll pan this first ambient track all the way to the left and the second ambient track all the way to the right and hit play. And of course, you're going to need to experiment to see what sounds best for your particular situation, but you can visualize things by adding the surround analyzer effect to a track or bus 1. So I'm going to, on bus 1, click plus, come down to meter and choose surround analyzer, and we'll play this back again. And this lets us visualize where the sound's coming from. Let's close that for now, and we'll delete it. Let's open up the pan controls for ambience 1. And for this stereo track, we also have this spread control. This lets us set how spread out the sound is. Full means it's spread over the stereo field, but as we reduce it, it sounds like it's feeling from coming from a narrower range or a smaller range in the stereo field. I'll play this back and change it so you can hear what it sounds like. So in other words, for a multi-channel source, i.e. not mono, it sets the distance between the sound sources. When we set this all the way to PNT, which is short for point, this means a single position in the stereo field. So with this set to point, I'm going to play this back and then I'm going to pan around and have a listen. It makes it sound like that stereo track is coming from a single point as opposed to spread out. Both mono and stereo tracks have access to this divergence control, and divergence sets how much of the audio signal is distributed to additional speakers in a stereo or surround sound mix. We can use it to set the perceived size of the audio source. What I'm going to do is reset these panning controls for both ambience 1 and ambience 2. You can also click here to reset everything. So let's suppose that these two ambience tracks here are actually supposed to be part of the same machine that's causing some kind of noise when the crew are entering the new spaceship. Let's go and add a submix bus. What we're going to do is we come up to the Fairlight menu, choose bus format, and we're going to add a new bus. Let's call this bus SFX machine, and we'll give it a color of tan and click OK. Next, we're going to use the bus output to send ambience 1 to the SFX machine bus and also ambience 2 to the SFX machine bus. We're also going to want to solo these. For ambience 1, I'm going to pan this hard left, and for ambience 2, I'm going to pan this hard right. We've got signal going to the SFX machine bus, but we've got no audio. That's because we have to select bus 1 as the output. Because we've panned this hard left and hard right, each of these two separate ambience tracks are now coming out of the left and right speakers in the SFX machine bus. Now we can open up the panning controls for the bus, and we can control how this machine sounds in the stereo field. So the first thing we're going to do is, I'm just going to play this back, and we're going to reduce the spread to make it sound like one machine. The next thing we're going to do is we're going to pan it a bit off to the left, somewhere about there. And then we can adjust the divergence to make it sound like it's coming from a bigger or smaller machine because it's taking up a wider part of the stereo field. So I hope you can hear just how powerful volume and panning can be, and we haven't even added EQ or compression yet. Panning and volume, when combined with EQ and dynamics processing, can really elevate your soundtracks and take them to the next level. Let's start off by using EQ to control and improve the tones in the audio. As we learned in Module 1, the range of human hearing typically starts from about 20 Hz all the way up to about 20,000 Hz or 20 kHz. The range of human hearing can be divided into three sub-regions. The bass frequencies, or the low end, about 50 to 250 Hz. The mid-range frequencies, or the mids, about 250 to 2300 Hz. And the high frequencies, or the high end, from about 2300 to 20,000 Hz. The fundamental frequencies for human voices are in the low end and the lower part of the mid-range and are generally different between men, women and children. You can think of the fundamental frequency as the frequency anchor that a person's voice is based on. It's not just that one frequency though, it's also made up of other frequencies all combined to make that person sound like them. For men, the fundamental frequencies are approximately in the 80 to 180 Hz range. For women, this is about the 165 to 255 Hz range, and for children, approximately 250 to 300 Hz. As we learned in Module 4, EQ allows us to boost, increase in volume, or attenuate or cut, reduce the volume of different frequencies. And some general advice is when we boost a frequency, we use a wider Q factor, and when cutting a frequency, we use a narrower Q factor. For dialogue, we don't usually want to boost or cut more than 3 decibels unless you're using a narrow notch filter to remove problem frequencies, or you're working with the high and low pass filter in bands 1 and 6. You can even use EQ to create effects, such as the sound of someone talking on the phone, and there's even a Resolve EQ preset for that.
Everyone, when we enter the ship, set up standard defensive posture.
Let's just reset that. In this course, we're going to focus on 2 main uses for EQ when mixing: dialogue improvement, sometimes called dialogue sweetening, and EQ carving to improve the clarity of dialogue when other tracks are playing. We'll start off with dialogue improvement. Getting good at using EQ to sweeten dialogue takes practice, but let's start off with a quick cheat sheet to help you understand what different dialogue frequencies do. For the 100 to 300 Hz range, if this range is set too quiet, then the overall sound can sound too thin or too weak. And if this frequency range is too loud, it can reduce the clarity of the dialogue. The 200 to 500 Hz range, if this is set to the correct loudness, it can make dialogue sound warm and inviting. If this is set too loud, it may sound like the dialogue was recorded in a box. From 250 to 750 Hz, if this is set too loud, it can make the dialogue sound muddy or unclear. And from 600 to 1 kHz, if this is set too loud, it can make the dialogue sound nasally. From 1 kHz to 3 kHz, you can change this frequency range to make speaking easier to understand. And from 3 to 6 kHz, you can increase this range to add presence or clarity to the dialogue. From 5 to 8 kHz, you can change this range to affect the sibilance, so this is sounds like sausages. And from 9 to 15 kHz, you can change this to adjust the crispiness or the sparkle of the dialogue. From 10 to 20 kHz, you can adjust this to change the airiness of the dialogue. Because every person's voice is different, there's no one magic EQ setting that will work on all voices, but there are some common things you can do that work on most voices. So we've got the Captain's track soloed. We're going to go and open up the EQ controls for this track by double-clicking on EQ. We'll start off by disabling all of the bands, just to simplify things, and we're going to play back with no EQ changes made yet, and we're going to look at the frequencies in the EQ window.
When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go!
You can see in this area here is where most of the frequencies for this person are sitting. The first thing we're going to do is enable band 1, and recall from earlier in the course, this allows us to cut out the lower frequencies. We're going to adjust the frequency to about 80 Hz, and we can choose the filter slope. The more aggressive this is, the more likely we are to introduce potential artifacts. So we're going to start with a 12 dB per octave slope. This is going to help us cut out any sounds that don't really contribute to the person talking. If you do this and you still feel like you've got too much unwanted rumble in the low end, then you can increase this to 18 or 24. Or alternatively, fine tune the frequency. I'll play this back.
Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1.
So we shouldn't hear too much difference in the sound of the person talking, but we can reduce some of the low-end rumble doing this. The next thing we're going to do is enable band 3. We're going to set the Q factor to about somewhere near 2.3. And we're going to set the gain all the way up to about +10. Doesn't have to be perfect. And then while we're looping playback, we're going to listen while adjusting this frequency backwards and forwards. This is called sweeping. And we're going to go from about 200 to 600 Hz. So we're going to sweep from about 200 all the way up to about 600 while the audio is playing back. What we're listening for is to see if those frequencies sound better or worse if we boost them or cut them. So let's go and do that.
Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the ship.
The next thing we can do is do that sweeping again, but this time reduce the gain to about -10. And what we're trying to do here is we're trying to work out if boosting or cutting this frequency range is going to make the annoying parts of the voice worse or better, and if it's better if we boost or cut this frequency range. Let's listen to this.
Set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive posture.
So I feel like for this specific clip that reducing the gain around 430 Hz helps to make things sound a bit clearer, but we don't want to cut by -10. When we're working with dialogue, we don't really want to go much more than +3 or -3. So what I'm going to do is I'm going to reduce this to about -2. We'll play it back and then we'll adjust.
Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive posture.
We'll leave it like that for now. The next thing we're going to do is enable band 4 by clicking on it, and we're going to use this to make the person's voice feel more present, which occurs approximately between 3 and 6 kHz. So we'll set the frequency to start at about 3. We'll set the Q factor to about 2.3. We'll set the gain anywhere from +5 to +10. And then we'll play back and sweep between 3 to 6 kHz and have a listen. And as you move higher, you might notice an increase in sibilance. This is where the S sounds stick out way too much. All right, let's do that.
3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive posture.
So you can see when we boost about the 4.8 kHz range, the S sounds are being elevated and they're kind of starting to get annoying. So what we can do is once we know that we don't want to go there, we can lower the frequency to try and reduce those S's.
Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive.
So something about there should work. And what we're going to do now is once you've found where that S sound gets elevated, you can reduce the frequency by about 1 kHz to maybe 1.5 kHz. So let's drop this down to 2.5 and then we're going to lower the gain once again. So we're not gaining by more than +3. We can play this back and fine tune.
Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter.
Also, while playing back, it's a good idea to toggle on and off the entire EQ just so you can hear what's happening.
Set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive posture.
So you can enable these other bands to make further changes to either fix problems or continue to sweeten the dialogue. And remember, the more you practice EQ, the more trained your ears will get to notice different frequencies. So the next thing we'd want to do is go and set the EQ for the officer. To save time, I'm not going to do that here. The second use for EQ that we're going to look at is called EQ carving. This is where we cut or carve out a wide section of frequencies out of the background music or sound effects so it doesn't compete with dialogue frequencies. So we can use this technique on any background sound, but we'll do it for the music track here. So I'm going to solo the music track and we'll solo the dialogue tracks. And we'll just expand this across so we're not listening to the same thing over and over again. Next, we're going to open up the EQ controls for this music track, and we're going to start looping playback.
Captain, we have positive lock. Pressures equalized. Ready to open the hatch on your command. Safety's off, everyone. When we enter.
Just going to turn off all of these bands. We'll leave band 3 active, and we're going to set band 3 to plus 20 dB with a Q factor of 0.3. We're creating a really wide bell shape. While we're playing back, we're going to sweep approximately from about 100 Hertz to about 600 Hertz while the music's playing back. And we're going to notice how these frequencies interfere with the clarity of the dialogue. This is because these frequencies in the music are competing with the important voice frequencies, including the voice fundamentals. So what I'm going to do is play this back, and we're going to sweep and find the frequency where it makes the dialogue sound the most distracting or reducing the dialogue's clarity the most.
For the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! Captain, we have positive lock. Pressure's equalised. Ready to open the hatch.
So I feel like about 425 Hertz is where the music really starts to interfere with the vocals. Once we find that, what we can then do is reduce the gain to negative 20. And we're going to play back and sweep again. And this time we're going to listen for where it makes the dialogue sound the most clear, but at the same time doesn't make the music feel less powerful.
Everyone, when we enter the ship, set up standard defensive posture.
Now recall earlier that we lowered the clip volume of the music track. You may want to increase the gain here just to make up for that.
Posture. Opening in 3, 2, 1. Go, go, go! Captain, we have positive lock. Pressure's equalised. Ready to open the...
So I feel somewhere around there is going to give us the best result. Once you've found the frequency that you want to work with, you can experiment with the gain for that frequency range, anywhere between -5 and -10 gain reduction.
On your command. Safety's off, everyone. When we enter the ship, set up standard defensive...
And of course, remember to reset the EQ gain. You could go and do the same thing for the sound effects and also for the ambience tracks. In this case, we could use the ambience submix, but to save time, I'm not going to do that in this course. The next thing we're going to look at is dynamics, and we're going to use compression to further enhance the dialogue. Just going to unsolo this, and recall that a compressor allows us to compress the dynamic range of the audio. We can use a compressor on dialogue to get the result of making the quiet parts of talking louder and the louder parts of talking quieter. Remember from earlier on the meter, the dynamic range for dialogue should be about -20 for the most quiet whispering, up to about -10 for a person with a louder voice. That's a dynamic range of about 10 decibels from the quietest human whispering to a voice on the louder side when a person's talking. When it comes to adding compression to a dialogue track, it will be easier if the clips on the dialogue track have all been previously balanced a bit, so it makes it easier to set up the compressor settings. So let's start off by working with the captain's dialogue track. We're going to solo that, and we'll loop playback, and we'll open up the dynamics section for the captain. So let's just play this back.
Opening in 3, 2, 1.
So at the quietest point on the input meter here,
Defensive posture. Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the
we're probably looking at about -16 or 17. And for the loudest part,
go, go, go! 1. Go, go, go! Go, go, go!
We're looking at about -8 or -7. So our dynamic range for the captain, at least based on this clip's playback, is from about -17 to about -7. So that's a dynamic range of about 10 decibels, which is about right for the dynamic range from a quietest human whispering to a voice on the louder side, which is what this captain is. The reason that we've got this reasonable dynamic range to start with is because earlier we went and used clip level automation to make this shouting part quieter. So when we're using compression on a dialogue track, a good place to start is this dialogue compression preset. And then for compressing normal dialogue where people are talking or having a conversation, we can start with a ratio anywhere from about 1.5 all the way up to about 3:1. This range will keep the compression from being too noticeable, but still help balance out the dialogue. So let's start with -2 somewhere in the middle, and we're going to loop playback this clip, and we're going to adjust the threshold and watch this reduction meter here.
Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go!
For dialogue tracks that feature a louder voice or a voice with more dynamic range, you can lower the threshold to get the desired dynamic range, and you can also reduce the attack time here to make the compressor kick in more quickly for those louder parts. But you don't want to make the threshold too low, as the dialogue will start to sound a bit unnatural like this.
When we enter the ship, set up standard defensive.
So let's just go and set that again.
Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive posture.
Looking at the output meter will show you the highs and lows after compression is doing its thing. If you hear the compressor making the dialogue sound too unnatural, you can raise the threshold a bit or reduce this ratio a bit to get it sounding more natural. One rule of thumb is to aim for about 1 to 3 decibels of gain reduction on average using this gain reduction here. So let's try and get that happening.
Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go!
So you can see I set things up there for the normal level of talking. We're just getting a tiny bit of gain reduction, but when the captain says go, go, go,
go, go, go,
we're getting as much as just a bit over -3 gain reduction. So the next thing we do is add compression to the other dialogue tracks, and we can even add them to the sound effects tracks and ambience tracks if they have a big dynamic range, just to try and keep things under control. Let's take a look at automation next. We have this section here where the captain is counting down. These sound effects represent the door opening or the hatch opening. The captain says go, 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 and then some action takes place. The team exiting the shuttle and piling out into the abandoned ship. So for that part, we want the music to swell up in a dramatic way. There's no dialogue in this section here, so the music is going to come up to fill in that void and give a bit of drama. So we can use track level automation for this. All right, let's go and increase the size of this music track so we can see what's happening. We've already got automation toggled on here. So what we're going to do is we're going to select fader level for the automation, and we can use any one of the tools that we learned about earlier to create this automation. In this case, what I'm going to do is we'll just make sure we can see where we actually want this music to get louder. It's in this section here. So we're going to increase the volume of the music to about here, and then before people start talking again, we can reduce the level. I've got the focus mode tool active, so I'm going to hover over this automation line and just bring it up. We can play back to listen to this. And let's listen to this back in the context of everything.
Go, go, go!
But you can see on the meters here, we're still quite low and it doesn't sound very dramatic. That's because we set the clip level volume to be quite low. So even though we're boosting the fader by +10 here, it's not actually giving us enough volume. So we'll start off by undoing that track level automation. We'll exit track automation mode. And this time what we're going to do is we're just going to increase the level of the clip for this empty section. And now we're getting about -10 to -15. Let's boost that a little bit more. A bit too loud. And what we're trying to get to here is when this music track is playing back on its own, we're aiming for about -10 to -15 on the main output. It's a little bit too loud still. Let's drop it by 1 decibel. A tiny bit too loud still. We'll just drop it a bit more. Something like that. But of course now, when people are talking, the music is going to be way too loud. So this is where we're going to use automation again. We're going to do the opposite now. We'll click on fader level and we're going to reduce the level of the volume using automation up until this point. And another tip for you here, you can always select a point here. I'm just going to turn on snapping and hit M on the keyboard to add a marker where you want these things to happen. Just make sure you don't have a clip selected. And now we know before and after this, we want the volume reducing. So with focus mode selected and snap activated, going to drag this section here, and we'll lower this down and have a listen.
Captain, we have positive lock.
Too loud.
Pressures equalized.
Too loud.
Ready to open the hatch on your... Captain, we have positive lock. Pressures equalized. Ready to open the hatch on your command. Safety's off, everyone.
Reduce it a bit more.
Captain, we have positive lock. Pressures equalized. Ready to open the hatch on your command. Safe.
So that's very subtle, but that's about right, I think, for the moment. We now need to do the opposite. After this, we'll just tweak this here, and we'll lower this down to the same amount.
No sign of movement, Captain. Looks like backup powers were...
Right, let's have a listen to that.
3, 2, 1. Go, go, go!
So we're not quite right there, but we can go and adjust that. We'll just zoom in, grab the pointer tool. So we want the music to crescendo there. We're going to drag this point and move it to the left. This is going to allow us to fine tune it.
Go, go, go!
Still a bit too late, so we'll drag this across a bit more.
Go, go, go!
And we'll also drag this point across.
Go, go, go!
And when the music goes quieter, we want it to drag down. Remember that you've also got the pencil tool. So if you want to draw this slope yourself, you can. And we'll do the same thing this side.
Go, go, go! No sign of movement.
And you can continue to fine tune that. Remember earlier that we also added this EQ carving, so we can also automate that. I'm going to select EQ and I'm going to choose on or off. This allows us to automate whether the EQ is on or off. So what we can do is we can actually turn off the EQ carving for this section, and that will give the music more fullness. And watch what happens down here when that EQ line is hit. This section will turn grey.
Go, go, go!
But because we're turning off the EQ carving, it's also going to make the overall music louder because we're not cutting all of these frequencies. So we need to come back to the fader level and we can adjust this.
In 3, 2.
So we're getting somewhere between -15 and -10. And then we can use the pencil tool just to tidy this up.
In 3, 2, 1. Go, go, go!
That's still a bit too loud. Let's go tidy that up.
Go, go, go!
And there is a little bit of a jarring effect when that EQ turns on and off.
Go, go, go!
So you may or may not want to use that technique. It just depends how quickly that loudness of music is ramping up and down. All right, let's go and have a listen to that final mix. Of course, you can spend more time on this than I'm doing in this demo.
Captain, we have positive lock. Pressures equalized. Ready to open the hatch on your command. Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! No sign of movement, Captain. Looks like backup power's working at least. No sign of a firefight, no blood. So where is everyone?
And that's starting to sound pretty good. I think the music here is a bit too loud, but we could continue to finesse that if we wanted to. You could also implement something like sidechain compression to automatically lower the music when the dialogue is being spoken. You could add submix buses to make further mixing easier. For example, you could add a submix bus onto which all of the sound effects tracks are routed. This would let you control the level of all the sound effects using one fader and apply common effects like reverb or EQ to all sound effects. Just remember to listen back with fresh ears after after a break or even the next day to give your brain and ears a chance to forget what you were listening to. You'll often hear things that need to be done or that you missed because you get used to sounds really easily. Once you're happy with your mix, the next step is to check the loudness. So that was a big module, and I hope you can get an overall idea now of the workflow you can use when mixing sounds and tracks together. Even though we didn't go and add EQ for the second dialogue track or for the sound effects or add compression to the sound effects, I hope now you understand a general workflow you can use when it comes to mixing everything together. In this module, we started off by editing the dialogue tracks, and that's because the dialogue is usually the most important piece. We made some initial dialogue edits, and we also moved each person to their own track so we could apply EQ and things like that to each person's voice independently. We went and did some initial balancing of the levels of the dialogue clips, and we saw that we can use clip level automation to clean up things like lip smacks or tongue clicks, and we saw we can apply micro fade-ins and fade-outs. We also saw how we can use the voice isolator tool to reduce background noise for vocals or dialogue tracks, and then we started the mixing process. We used 4 things when mixing the different tracks together. We used volume, panning, EQ, and dynamics. And finally, we saw that we can use automation to further fine-tune and refine the overall mix. Now we have the mixing complete, it's time to get ready to deliver the project. This could be delivering a final exported file to a client or uploading it yourself to a platform such as YouTube. Mastering refers to the final step before delivery, where we check that the program's levels meet the required standards. Audio mastering and delivery is a whole specialized topic in and of itself. There's many tools that can be used during mastering, such as multiband compressors, corrective EQ to get rid of unwanted resonance or frequencies, stereo width manipulation, and specialist mastering related plugins. In this course, we're going to focus on the loudness component of the mastering phase. This is possibly the most important aspect of mastering when it comes to delivering to a specific standard. So in this course, we're going to start off by learning about some of the meters we can use to help us out. The first is the true peak meter. This allows us to check what the maximum signal level was as we're playing back the video. Next, we're going to look at the loudness meters, and there's a few different ones that we can look at when it comes to loudness, but there is one specific value that is the most important when it comes to delivering to a certain standard. Once we understand how to measure loudness, we'll also see how we can manipulate it, and this is part of the mastering phase. We'll learn how to set a target for a specified standard and how to manipulate loudness to meet that standard. So here we are back in Fairlight, and this is the mix that we were working on in the previous module, and I've kept this mostly the same. I've made a few small tweaks. For the fader level automation on the music track, I've just replaced that hand-drawn curve with a more gradual increase in fader volume, and then we drop it down. And I've also replaced the EQ on-off automation with the band 3 gain automation. And recall, we were using this EQ setting on the music track to perform EQ carving for when the dialogue was being spoken. When there's no dialogue being spoken, we're going to modify the band 3 gain from negative 9.5 when the people are talking to this setting here, negative 3.6. So that's just going to let some of the music's richness return when there's no speaking, because we don't have any dialogue that it's going to be competing with. Let's just go and change this to none, and we'll turn off the mixer. We're going to be looking at the loudness component of the mastering phase. To complete this phase, we're going to need to use some extra meters. There's different types of what we might think of as loudness or volume that we can use meters to measure. We've already seen in the mixer here, we've got these channel strip meters. These are RMS meters, and we've already seen these, so I'm not going to focus on those in this module. If I close the mixer down and then open up the meters, we have some additional things we can look at. There's two main things we need to look at. The first is the true peak meter, or TP for short. This tells us the peak of all of the audio channels that are playing back together. And remember, by default, that the audio tracks are routed to the main bus 1. As well as the true peak meter, we're also going to need to make use of these loudness meters. As the name suggests, these meters measure loudness, but using the loudness unit scale, or LUFS for short. Let's start off by talking about the true peak meter. This tells us what the loudest point or peak is when we're playing back. Let's play back a section and watch what happens in this entire control room section.
3, 2, 1, go, go, go!
You can see we've got this value, negative 12.4, for the true peak value. The true peak value in the control room measures something called inter-sample peaks. In simple terms, this is what the real true peak output is when the digital sound is converted back to analog signal for output to speakers or headphones. Different delivery targets, like streaming services, have standards for maximum true peak level allowed and also loudness, which we'll get to in a second. You can quickly select the target that you're aiming to deliver to by clicking these 3 dots here and then choosing one of these standards. Let's start off by selecting the Netflix standard and watch what happens up here. You can see in the loudness meters, this value has changed. We've got this white number, negative 27. If I change this to YouTube, we've now got a different number in white, negative 14. This is the loudness target, which we'll talk about in a minute. When we use these presets, such as YouTube or Netflix, it's also setting the true peak maximum standard. You should always double check what your delivery standards are before exporting the final file and, in fact, even starting work on the mastering phase. So let's just change this back to YouTube. And for YouTube's standard, the maximum true peak is negative 1 dB TP, or decibels true peak. That means if this TP value goes above negative 1, then we're not going to be hitting the YouTube standard. So I'm just going to play back a section.
Go, go, go!
Notice that the true peak value is in this blue color, and that means we're not exceeding whatever maximum true peak target has been set. What I'm going to do is open up the mixer, and we'll just make some extra space here, and I'm going to change bus 1, and I'm going to increase the fader level, and watch what happens when we're playing back. You can see that true peak value is increasing. The maximum loudest point is increasing because we're increasing that bus 1 fader. So let's go and really max things out. I'm going to open up the dynamics section and I'm going to increase the makeup gain to 20, and let's play back this section now.
Go, go, go!
Now the true peak is negative 2.4, so we're getting closer to that maximum negative 1 for the YouTube standard. Let's go and open up the EQ and also increase the gain and play this back again. And you can see straight away this TP value has turned red because not only are we above negative 1, we're at a whopping plus 13.7. Let's reduce this down. You can see at plus 0.8 true peak, it's still red. Let's reduce this a bit more. But at negative 1.3, the value is still blue because we haven't exceeded that negative 1. Let's just creep this up a bit.
Go, go, go!
And as soon as we hit negative 1 there, it turns red. Remember, there's different standards for the maximum true peak level depending on where you're uploading to or you're delivering to. Alright, let's just go and reset all of these faders so we're not going to blow up our speakers. As well as the maximum true peak value that we experienced during playback, the meter underneath it shows us the true peak in real time.
2, 1.
So you can see there this meter peaked about negative 15, and we've got negative 15.9 in the maximum true peak value recorded. In addition to true peak, there's also the measurement of loudness as measured in LUFS. LUFS measurement of loudness is different from the other meters because it factors in the human perception of sound. It measures what we as humans actually think sounds loud or quiet. It's different from just measuring the digital signal values. There's different LUFS values. And if we play back a section, you can see those moving.
Posture. Opening in 3, 2.
So the first meter is this M meter. This is the momentary meter. It gives us the current loudness level at the playhead for the selected bus that we're monitoring. Or more exactly, the DaVinci Resolve 19 reference manual describes this as, this meter describes LEQ equivalent sound level within a 400 millisecond window following the playhead as measured every 100 milliseconds. You can just think of this as the current loudness when you're playing back in LUFS. The momentary value also doesn't include the low frequency effects channel of surround formats because these aren't factored into loudness metering. The loudness meter next to the M meter shows the sum of all channels for the duration of playback. The number at the top is the maximum LUFS value over the range of playback. At the minute you can see this is negative 22.7. So if we play back another section,
ship set up standard defensive posture.
You can see that value is now negative 29.0. So for that short section that we played back, negative 29 was the maximum LUFS value for that range that we played. You can use these 4 loudness values to know if you're meeting whatever loudness standards you'll be delivering to. The first number we've got here, this negative 31.2, is the short value. This gives us the average loudness level over the last 30 seconds. The short max value gives us the maximum level over the last 30 seconds playback. The range value gives us the dynamic range in loudness units over the entire time you've been playing back. So the dynamic range for that short section that we played back was 4.4. The final value down here, this integrated value, is the LUFS value for the entire playback so far. So this integrated value is the one that you're going to be paying most attention to when it comes to delivering to a specific standard. But as I said before, you should always double check what the standard is because you may have other requirements for things like short, max or range. The color of these numbers gives you a quick and easy way to see where your loudness is at. Just like with the true peak value, these numbers will turn red if they exceed the target loudness. They'll be blue when they're under the target LUFS tolerance value, and these numbers will turn yellow when the value is within the tolerance for the set target. You still need to use the actual numbers to make sure you're complying with the standards you deliver to, not just the color of these numbers. As we saw before, when you change these preset targets, let's change it from YouTube to Netflix. Now the target here in white is negative 27. Let's just change it back to YouTube for now. Now we can see the target for YouTube is negative 14. If I play this back,
opening in 3, 2, 1.
We get all of these numbers, but if I start playing back again,
opening
those numbers disappear and it starts from 0. You can manually reset these numbers by clicking this reset button. When you do that, notice this button changes to start, and if I play back now,
set up standard defensive posture.
You can see we don't get any numbers for short, max, range and integrated. That's because we're no longer measuring loudness, and to start measuring again we need to click the start button, and we can see now
posture. Opening
that we get these numbers again. One really useful option that you should know about is the option here to lock metering to transport. If I enable this by clicking it, and you can see that it's ticked now, and start playback, anytime I move to another area, it's going to reset these values.
In 3, 2, 1. Go, go. Have positive lock. Pressures equalized. Ready to open the hatch. Movement, Captain.
And you can see there, every time I started playback from another section, it reset all of those values. There's also another option up here, whether or not to have absolute scale ticked. Currently it's ticked, but if I untick this, you can see that the loudness meter here changes. And if we play back,
when we enter the ship, set up standard defensive posture.
This is giving us now a relative level because we're not using absolute scale, and in this case the white 0 here represents the target that we're aiming for, and the meters show us how far away we are from that target. Personally, I prefer to use the absolute scale as I think it just makes a bit more sense, but you can use whatever you think helps you the most.
Captain, looks like.
And you can see here that we're quite far below the target negative 14. So we need to know this integrated value for the entire thing we're going to be exporting and delivering. One way to do that would be to hit home and then just play back the entire thing.
Captain, we have positive lock. Pressures equalized. Ready to open the hatch.
And by the time you get to the end of the program, you'll know what this integrated value is for the entire thing that you're going to export. The second way you can help visualize loudness is if you come to your bus 1 here. This is the default bus, and we'll expand this out. to give us a nice big view. You can see that when we expanded this down, we get this loudness toggle, and we can choose what we want to measure here. We're going to measure integrated loudness. We can turn this on and then start playback, and as it's playing back, it's going to give us this line, which is going to give us the loudness. You can also see, because we selected the YouTube target, it's telling us the white line here, -14, is the loudness we're aiming for. So I'm just going to play this back.
Captain, we have positive lock. Pressures equalized. Ready to open the hatch on your command. Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1. Go, go, go! No sign of movement, Captain. Looks like backup power's working at least. No sign of a firefight, no blood. So where is everyone?
And this gives us a really nice view in graphical form of where the loudness levels are sitting within the entire timeline. You can see this bump here is where that music swelled to a crescendo, but we're still quite far away from the target loudness value of -14. There's another really quick way to measure loudness. The first thing you want to do is make sure you don't have a range set or in and out point set. You can quickly remove a range if you've got one set by using Alt-X on the keyboard, and then come up to the timeline menu and choose Bounce Mix to Track. What this is going to do is it's going to play back everything from a specified bus and create a single audio file from it. In this case, we want to bounce bus 1. That's our main output bus. So we want to measure the loudness for the main output, and we're going to choose a new track here and click OK. It's going to play back really fast, and now you can see we've got this new track, audio 9, and this track contains all of the audio that was being played back to bus 1. And if I solo this, you can hear it contains all of the other tracks. Once you've bounced this, you can right click on this new WAV file, come up and choose Analyze Audio Levels. It defaults to any loudness standard that you've selected up here earlier, in this case YouTube, and it's also telling us here that the loudness standard specifies a true peak of -1.0 and an integrated loudness of -14. And now we can just click Analyze and really quickly get an idea of where our true peak and integrated values are sitting for the entire program that we bounced to that new WAV file on the Audio 9 track. So we're quite far away from the maximum true peak value, and we're quite far away from the target integrated loudness. We're going to take a look next at how we can actually manipulate the loudness and get these values a bit closer to where they need to be. Going to close this, and always remember to select this bounced WAV file and delete it. Otherwise, you're going to get very loud signals because you'll be duplicating audio, and also you can go and right click and delete this added audio track. Audio mastering and delivery is a whole specialized topic, and mastering can include loads more things in addition to loudness, such as EQ adjustments and stereo width adjustment. But in this fundamentals course, we're going to focus on one of the main things when it comes to mastering, and that's loudness. So we just saw different ways to check loudness, but what can we actually do about changing it? We've already seen many ways to manipulate volume and dynamic range, including adjusting clip volumes to even out sound levels and reduce dynamic range. We've seen that we can use channel strip compressors to control dynamic range, and we've seen that we can use automation to adjust fader volumes over time to bring up quieter parts and reduce louder parts. They were all things we looked at as part of the mixing process. So one way to manipulate loudness is to use a limiter effect on the main bus. Let's just reduce the size of these meters, and on the main bus we're going to click the plus to add an effect. We're going to come down to dynamics, and we're going to add this limiter effect. A limiter reduces peaks in the signal that go over the ceiling setting. This means the overall signal can be boosted, but the peaks brought down or limited to a set ceiling value. This has the effect of reducing the dynamic range and increasing the overall loudness level. A limiter is similar to a compressor, but this effect plugin is a true peak limiter, and it looks 64 samples ahead in the future to check the input signal and any peaks that are coming. There's a few different sections to this limiter plugin. We've got the input meter. This is the level of the signal as it's coming into the limiter before limiting is applied. We have the input level. This allows us to boost or cut the incoming volume level before it hits the limiter. The soft button makes the limiter use a softer attack speed to get a less noticeable limiting effect, but this might mean quick transients or sudden increases in peak volume may not be limited as quickly, so it can be a trade-off. The ceiling value is like the threshold in the compressor we learned about earlier in the course. If the input signal, after it's been modified by this input knob, rises above the ceiling value, then the limiter will kick in and start to reduce the volume. You can alter all of these things by dragging the mouse button on the knob or clicking in the value and typing in a number. The release knob is how long the limiting or the signal reduction takes place after the ceiling is exceeded. The reduction meter shows the value of any gain reduction being applied, or in other words, the limiting that's being applied, or how much the peaks are being brought down, and the output meter shows the output level after the limiter effect. So we can start by choosing a preset as a starting point. Let's go and choose Transparent Master. This is going to give us some default settings for the ceiling and the release. We're currently on the YouTube preset here. So we know that the true peak is -1. So we're going to start by setting this ceiling value to -1.5 just to give us a little bit of wriggle room when we're starting our mastering process. If we modify this input level, it's going to either make the input signal to the limiter quieter if we make a negative value, or louder if we increase it. If I just play back a small section,
Open the hatch on your command.
This grey section that's moving across is the input signal. What we want to do is increase this input until that grey line gets closer to the blue line. The blue line represents the ceiling that we've set. So what I'm going to do is hit home to go to the start. I'm going to hit playback, and then I'm going to modify this level in real time until we start to see some gain reduction happening here. And while I'm doing it, I'm also keeping my eye on the loudness meters.
Captain, we have positive lock. Pressures equalized. Ready to open the hatch on your command. Safety's off, everyone. When we enter the ship, set up standard defensive posture.
So you can see I increased it a bit too much there.
Pressures equalized. Ready to open the hatch on your command. Safety's off, everyone.
Okay, so we're getting closer to that blue line. So the integrated loudness for that bit that we played back is -21.6, which is still quite far away from -14, which is the target. And the true peak value is -3.5. So we've still got a bit more wriggle room with the true peak value as well.
We have positive lock. Pressures equalized. Ready to open the hatch on your command. Safety's off, everyone. When we enter.
So we're still not getting much gain reduction.
Safety's off, everyone. When we enter the ship.
You can see we've got a little bit there because this grey line went above the blue line. So what we're going to do is we're going to come to the start of the timeline. We're going to choose bounce mix to track. We're going to bounce bus 1 to a new track. And when this bounce has completed, we're going to right click, choose Analyze Audio Levels, and then choose Analyze. You can see now that these values have turned yellow, which means that we're getting into the ballpark of where we need to be. You can also close this down and expand bus 1 down. And I'm just going to play back the entire thing. Of course, remember to delete this WAV file or delete the entire track. This is the audio that we just bounced, and I'm going to play this back, and I'm just going to skip ahead so you don't have to listen to the whole thing again.
Captain, we have positive. Where is everyone?
You can see now that the integrated value is -6.5, the true peak value is -1.6, which is very close to the ceiling that we set of -1.5. Also, it's interesting to note that during the music, our integrated loudness gets even closer to the target loudness of -14. This could give us a clue that we've got that music section set a little bit too loud. So in that case, we could go back to the mixing process and reduce that section a bit if A, the value on this chart is going really high, or B, our ears are kind of hearing that, yeah, maybe it might be too loud. Let's continue for now. I'm going to increase this level even more, and I'm going to play back the section where that music kicks in. And what I want you to watch now is this reduction meter.
Go, go, go!
You can see this line has turned red now. The integrated value has turned red up here because we're exceeding the loudness standard.
On. Go, go, go!
Now this line has turned yellow, which means we're in the ballpark. And on the integrated meter, we've got negative 14.3. So as we did before, I'm going to bounce the entire mix to a new track. Right click on that track, choose Analyze, and the integrated value for the entire program is negative 16.2, but we know that for some part of the track, that value is higher. So let's go and delete this bounce track, and let's suppose that we actually do think that that music is too loud and it's really overpowering things. By reducing the value for the fader level for that section, we can actually increase the overall loudness for the other parts of the program. So let's go and reduce this by 3 decibels and play it back.
In 3, 2, 1, go, go, go!
And we can continue to tweak this. And now we can do the bounce trick again, analyze that, and then continue to make changes to the limiter. We'll increase the level just a bit more, and you can continue to finesse things until you get the overall LUFS level for the program that you want. Remember that the YouTube standard specified a maximum true peak of -1. We've currently got the ceiling set to -1.5. So we can further increase the loudness by reducing this to -1, and that's going to allow higher peaks. We can now increase the level a bit more.
We have positive lock, pressures equalized, ready to open the hatch on your command. Safety's off, everyone. When we enter the ship, set up standard defensive posture. Opening in 3, 2, 1, go, go, go! No sign of movement, Captain. Looks like backup power's working at least. No sign of a firefight, no blood. So where is everyone?
This blue line is telling us that we can still push the loudness a bit more if we wanted to. So we continued to increase that input level, and you can see the loudness line is yellow, which means we're in the ballpark, and we can once again check the total loudness by bouncing and analyzing. And that's looking pretty good now. We're under the maximum -14 integrated loudness. Here it's telling us it's -14.1. This is for YouTube. And we're not exceeding the maximum true peak of -1. Our maximum true peak is -1.2. Always remember to delete the bounce track. Just one last thing to mention when you're using this limiter is that the more gain reduction you see in this meter, the more potential you've got for things to start to sound unnatural. In addition to using these meters, always listen to what's happening in your speakers or headphones. So when you're happy that the loudness levels meets the standards you need, you can go and export your video and give it to your client for checking or upload to something like YouTube. So that brings us to the end of this module. In this module, we started off by looking at the true peak meter. This meter allows us to check what the loudest point or peak was during playback for the section that we played back, or if we play back the entire program, the maximum true peak level for the entire timeline. We also learned that the true peak meter takes into consideration the concept of inter-sample peaks, which is a way of measuring the true peak as if it's being converted from the digital to the analog signal and coming out of the speakers or headphones. In addition to the true peak meter, we also looked at the loudness meters. We learned that loudness is measured in LUFS and that it takes into account the human perception of sound when it comes to measuring loudness. We also learned that one of the most important values is the integrated LUFS value for the entire video, as that's the value that's often specified when it comes to loudness targets for different platforms, but you may need to check if there's any other requirements when it comes to loudness. Once we understood how to measure loudness, we saw one way of manipulating loudness during the mastering phase, but we mentioned that mastering is a specialized topic or role, and it can involve more than just loudness manipulation. We saw how we can add the limiter plugin to allow us to increase the overall loudness for the timeline.